So this is yesterday's parts. So basically, this is the task that we stated yesterday. 100 fitness centers were deciding to receptionists that are doing upsells and to see what happens. They will have to calculate the ROI. Yes, retention rates are the key metrics here. I've done it with revenue, but we can do the same with retention rate because retention rate is also a continuous variable, which would also have same standard deviation, just in different scales. So, data quality assessment process. It's exactly what we discussed yesterday, but in different wordings. Basically, this is a guideline recommended by US government, which says in the first stage, we have to state a hypothesis and make a sampling design concept. We have stated a hypothesis, and in our case, a sampling design concept had some potential discussions, or not potential. We were discussing which way we should draw the sample. But the hint forward is that most of the statistical tools require either ordered data, paired data, so a subject before treatment, subject after treatment, or independently drawn samples. So all other kind of But by the way, these subjects, when they're selected before and after treatment, they're also selected randomly. So in all other cases, it's difficult to find out the statistical method to get a sound prediction of what is happening. So actually, tools limit our to random sampling in most cases, or the treatment to measure the differences before and after treatment. But with time and business, we are subjecting our experiment to a lot of confounding variables, which would influence our experiment. So, this is our hypothesis. So I decided to go through revenue per store. Number of stores enrolled in the test 10, number of stores in control group tests, and I calculated, I've estimated some of the numbers. So our average revenue is 100K, and initial standard deviation that I'm putting into the numbers is 5,000. So it actually means that standard deviation. Do you familiar with Six Sigma methods for production? Yeah. So basically, standard deviation is 1 sigma. So it means that in 99.95 cases, revenue of this, each fitness center enrolled would be in the bounds of 85 to 115. So all the normal distribution except a couple percent would fit into 3 standard deviations left and 3 standard deviation right. So we'll do some experiment how standard deviations influence the calculations, but our data is surprisingly clean because we will generate the normal distributions with the given parameters. But I did a slight tweak. In the choice of the tests, I've selected the tests that they're not very sensitive to the normality of the data. So they will also work out moderately well if data is slightly not normal. Wait, I'll open the iPython notebook. And I would encourage you not to click through, but to re-implement your version, but we can click through whatever you wish.
But our version is yesterday's state or?
No, it's the document that is called HT F Center's IPython notebook.
Yeah, but you're saying make a fresh notebook as well.
If you want to, well, let's do the following. Let's click through this example, and then you'll do your variant with retention by yourself. Hopefully not by copy pasting things. So, wait a second. So that's the notebook. No, this is the notebook, which I would zoom in. So we take the base revenue, 2,000 visitors, 2,000 visitors. I've estimated that the monthly fee is roughly $50, which is totally arbitrary number, but we can change and see what happens. So I've generated two normal distributions with base revenue and base revenue multiplied by 1.1 with slightly different standard deviations, which is kind of fine. So, and now we're coming into a very interesting place. This is how our histograms look like. It's just 10 points of data on the left and on the right. And if we will go further in statistical tests, we'll see that most of the statistical tests are not recommended to samples below 30. At least parametrical one. Non-parametrical one can be used on smaller samples, at least by the guidelines. But I did the simulation, and the parametrical tests also worked out really well.
So why do we measure just 10 versus 10 and not 10 versus 9?
It doesn't really matter because we can measure 10 versus 90. It will slightly increase the power. I think we'll need this. Usually, researchers tend to do equally sized samples in what they do, but generally we have a distribution 1 and distribution 2. If this distribution is noisy and we do not have most of the data, we would have more precise mean and standard deviation here. But generally it wouldn't change much because they are drawn from the same sample, from the same population. So if the setting is right, well, first, for the calculation purposes, it's fine. I did this estimation with A/B testing, 10/90, and it changes. Actually, we did it yesterday together. It doesn't change anything. So, yeah. Let's go through here. I'm struggling to put both code and presentation on the screen. Yeah, so if we would change the number of stores, our distribution would generally look much better and actually look like normal distribution, which you can check and plot them over each other. And then it gets better and better, but when we work with size 10, our distributions visually do not look like normal at all, unless we do statistical tests. So this is our distributions. the effect is pretty big. So, yeah, we're doing simple investigations. If we would deal with real-life data, I would encourage you to do more kinds of plotting, but since we generated it from randomly with random.
And in real life, what are kind of the typical problems you'll find in simple data investigation?
In real life, yeah, let's go to again. This is real life. So in real life, when first we have to check the sampling design, if it was actually random sampling or we have influence of confounding variables. And this is a small table here, which actually explains the steps that we did yesterday. So we have a goal of the study, we define the inputs, we define the boundaries of the study, which mean target population, temporal limits, etc. We develop an analytic approach, and we have a performance criteria, which is improvement by 10%, and kind of the plan for obtaining data. So, we basically check if everything is right. We go to Python, and basically we have to test. We have to select a statistical method to test our hypothesis. So theoretically, we have a normally distributed sample. So, since we have a normally distributed sample, we can use parametric tests. They have higher power than non-parametric tests on the same amount of data. But non-parametric tests do not really care about distributional assumptions. So what would happen in this case, if we're not sure about the distribution, we have to switch to non-parametric tests by default. And then there is a neat table which you can download to see it in a bigger size. It's also in the document. This is basically a decision tree of which methods to use. Then they are actually for continuous variables because they are comparing population parameters, mean, medians, differences in means, and tails for non-parametric distributions. So what we do, we have treatment group and normal group, so it is to sample. We hope that it is parametric, and we do not do tests because we're afraid, or at least I would be afraid of influence of the time and changes. I would do independent tests. So we have basically three things that the Environment Protection Agency statistics recommend us. T-test for equal and unequal variance. And there is a trick if we're not sure about distribution, we go to non-parametric and then independent. So again, here we have a distributional assumption that it has to have the same variance.
And why ANOVA is not here?
And ANOVA is not much recommended by the statistic guideline. It is in the guideline, but it is least recommended. ANOVA, first, it's a case sample, because ANOVA and there is MANOVA, which different kinds of ANOVA. It's in the manual, but it is used less often than t-tests. And what is interesting about t-tests that there are some guidelines online which encourage use t-tests on binomial distributions. So from one perspective, it's written that it has to be normally distributed data, but people still put in t-test the manual data, basically a list of ones and zeros. Literally, a list of ones and zeros, you put into t-test, one list versus another list, and you get more or less meaningful statistics. The proper method would be to use, for example, chi-square test of independence, which we had done yesterday, and actually it is in this guideline, but this is mostly, since we're treating continuous data, this is more appropriate. And this is t-test. We start to look for t-test. This is again the part of the manual. I'm just picking you a proper table, which is a proper page, which is probably 120 or something already. So, we need our populations to be independent. They do not recommend to use the test if our data set is below 30. But I tested it, and with generated distributions, it works fine, even with 10. Basically, they say if it's less than 30, use non-parametric procedure. It is in the notebook as well, so you can compare performance of parametric and non-parametric. Variances have to be approximately equal. Yeah, and then there are good things about t-test, why it is recommended by default. So it is robust to violations of assumption of normality, but not to large inequalities of variances. But when I'm doing simulations of variances, it doesn't influence as much as well, especially on this particular kind of data set. We're not measuring air pollution here, because we have 100K and meaningful standard deviation for the business. T-test would have a problem with an outliers. So if our sample was drawn randomly, we have to either start the thing that is called p-hacking. So basically manipulating your data so the p-value of your statistical test grows, which is considered to be a wrong thing. But if we have outliers, then t-test is not the best case. So it will be as precise. And regarding the t-test, it has two variants, with equal variance and with different variances. What is neat in Python? That there is stats test that we used yesterday, and one of the parameters is equal variance. So you can run the same test on equal variances and different variances. Or non-parametric test, which was recommended here. So basically, this one we discussed these two, because we want to find out if the stores start to earn actually more, or if we're not sure of our sample size is too small. We have again difference in means, same variance. You can run some test, and surprisingly, it works as good, at least on dummy data. It works as good as t-test. So what can we say about this? Same. Random sampling independence. So this makes us, it has to make us very strict for sampling criteria and for general experimental design. Same variance. May produce misleading results if there are many tied data values, because it is a ranking test. If there is a same amount of number repeating all the time, it cannot rank the measures, and then the quality of the test falls down. But if you put more precise measures, for example, up to dollars or cents, it would be fine. It would be able to range it anyway. So basically, what EPA recommends, you have to record the values with sufficient accuracy, so the test would work. If not, there is another test which can substitute it, and let's go to a notebook.
And that's percent the time value thing.
Yeah. I really like the guidelines, basically because you are literally given all the caveats of what is happening, of what can go wrong. So we plotted QQ graphs, which show a decent R-square, kind of look normal, which we cannot see on the histogram. Yours would be different because we haven't set a random seed, so a random number, set a random number generator on this computer works differently than on yours. So yeah, that's the t-test, independent t-test that we used before. And it basically says that statistically significant, it is very sure that the distributions are different. And we remember that distributions where one was 100K revenue with a particular standard deviation, another one was 10% bigger. So that's another one. Wait. I think I have non-parametric test.
So ranks and superior, I mean, these are all just.
This is rankings here. The rankings. This is non-parametric test. In Python, it's called rank sums.
So that's non-parametric.
Yeah, this is a non-parametric one, and it also says that it is pretty sure that distributions are different. And now, what is interesting that this statistical guideline recommends to do opposite. First we do a test and then we test in assumptions. So both tests expect that the variance is equal and the distribution is normal. We have already pre-checked the normality of the distribution in the QQ plot visually, but we can do a more formal test, which is Levin's test. It's the one that was not on the board yesterday, and it was not in the notebook. Why Levin's test? We go to presentation again. Yeah. So our first stage is we verify the assumption. Basically, our tools are to check distributional assumption, independence and trends, and dispersion. Dispersion means actually to measure standard deviation for distribution. In our case, we do not have dependent variables. There is no correlation. We have two independent groups and we have to prove that they have different incomes. So there is no point of correlating them to each other. So we remove the independence and trends, and we have distributional and dispersional assumptions. Again, when you start to check how to calculate the equality of variances, well, first, in our case, we generated the numbers by ourselves, so we can see that they are more or less equal. We can calculate the variances deterministically, just to take the bell curve, to calculate the variance, and say this is a number, this is another number, put them together and think if they're sufficiently different or not. But this is a statistical approach. There are few methods, which the number one method is actually called an F test, which you will find in the most tutorials, online, kind of, simple tutorials, where general Indian guys show statistic. But F test is very sensitive to departures from normality. So it does decent quality of estimating the difference of variances, but if your data is not normal or doesn't look very normally distributed, an F-test will fail with higher probability. So again, in statistical guidelines, you have either Levin's test or Bartlett's test.
So is Levine, is it so, less sensitive to partial normality? Is that all the way to being it's a non-parametric test, or it's still a parametric?
It's still a parametric test, but if your data is slightly not normal, it will say fine, I would still give you a decent estimate of probability. So for Levin and Bartlett's, it's what NLP recommends again, but I've picked the one that works better with better power with non-normal data, because we actually do not know what would happen in real life, and it is less sensitive. And it has greater power than Bartlett's for non-normal data. And in our case, for example, when we use non-parametric tests for non-normal data, we still expect same variances. So Levin test would be better. Levin, same as everything in SciPy, takes exactly one line to implement. Import Levin. Levin, if our probability is more or bigger 0.05, draw a conclusion. Which says they're similar, and we can play with numbers actually. So what we've done so far is we have checked the sampling, at least by the protocols or imaginary checked the sampling, plotted the data, checked if they look normal, if they look different, even on small samples, selected two statistical tests in case for smaller and bigger sample, conducted them, and verified the hypothesis of normality and equivariance. That's it. We have proven that the actual, even in case of nicely normally distributed data, the difference of 10% is visible. Now let's try something trickier. This is function from stats models, which can estimate. It's basically what we've seen online in the for A/B testing. That's the same, but slightly more flexible. Here you can put basically it works the following way: if the right effect size known and write all other properties of the experiment, it will return you effect size. If we will write a power as known, but we will fix the effect size, it will return power. So whatever you want to do, kind of any property of your experiment, if you have all other, you'll get the one that is missing. And effect size is basically the following. You take the difference of mean of the group 1 and mean of the group 2. So mean 1, mean 2. So effect size is mean 2 minus mean 1 deleted on standard deviation. How skewed is the graph? It's a solver for t-test, so it expects standard deviations to be almost equal on both distributions. That's it. So basically, because we know the standard deviations, we know what effect we can measure. And in our case, it will not work because there is no size. So with just go to this.
There's notes.
Number of observations.
And this is total or 50%?
No, it's 50%. So basically what it says, it's n obs 1. So it means in group 1 we have 10 observations. We have two-sided test. Ratio is ratio means n2 equal ratio multiplied on n1. So you can easily check what would happen with power if your groups would be unequal here. You just change the ratio. Power is statistical power, so it actually means that we lose one of 10 improvements. And alpha means that with 5% chance we think that we have an improvement, but we actually start to lose one. So I am returning an effect size with this setting, and actually effect size, so I multiplied the standard deviation and did the reverse calculation, and it actually says that with these settings we can notice the changes of revenue by 7.7%.
I don't understand how this function works if we do not give standard deviation.
We do. Well, here it's effect size. And effect size is basically how it moved. So I need to recalculate it. It returns the size of the effect, and then I use standard deviation, base revenue, and I move it back to the actual change money-wise, which we can notice. So we can notice we have a statistically significant method that can detect the changes 7.7%. There is one trouble with it.
Is that because effect size is kind of like a unitless number?
Yeah.
Okay.
No, I'm not sure if it is unitless.
It is only given by power, number of observations.
It's. Can you repeat?
So, I mean, from formula we see that if you know the power, ratio, and number of observations,
We have to know standard deviation as well.
we have the effect size.
Yeah, effect size, right? But after that, if our distributions are like this, the effect size can be not really visible, so we do not really see how much improvement we're getting. If they are very steep, then we can do the calculation.
It's 1.5 what? 1.5.
This is just an effect size. Effect size.
Yeah, but from the second formula, I mean from the line 157, we can say that the higher standard deviation, the better the effect.
So the effect size, the number of 1.5 standard deviations, I guess. Unit is deviations.
Yeah, so here effect size, here it is, it's mean difference of the mean between between distribution 1 and distribution 2 divided in standard deviation. And standard deviation is actually not a unitless number, so. Anyway, so what I wanted to discuss, it's two-sided statistical test. It has slightly less power. It has less power than one-sided test. But the trick is that in money decisions you cannot use one-sided tests because basically your improvement can be not really an improvement. So when we use one-sided tests, we do not investigate half of the changes. Our hypothesis is that we do not care if it goes back, but our hypothesis is true if it goes one way. So we will not notice the difference. Unfortunately, with this kind of test, we know how it will go both ways, but we will not notice the difference if our business will start losing 7% of the revenue per period with this simulation.
Хорошо.
We will see the effects bigger than 7% or 7.7. So if the effect of our treatment would be losing 3,000 per month per store, we would just reject the hypothesis. We would try to see the means, but all the decisions would be not significant. And here is a small simulation.
Sorry, one side, two side is the same, like single tail, two tail.
Yeah, so this is exactly the point. So you can use one-sided tests. You'll have better statistical power. You will be able to quantify your improvements. So your actually the effect size would be even. You will be able to see smaller differences, but on the one side.
And why here we didn't use one side?
Well, the only way to use one-sided, for example, if we accept or confirm the hypothesis our revenue grow, then we're safe from all other directions. But if if our revenue doesn't grow, it means that it might fall down, and we didn't check it. So we can try to do two hypothesis testing, but usually statisticians use just the proper tool. So if we want to be careful and see the differences below 7.7% in this setting, we actually have to increase the number of iterations. Now we are kind of on the safer grounds. We can statistically significantly notice the effects, which are 4% from revenue. Or we have to dig significantly deeper in data.
So the effect size, remember, this is the effect size that will be noticed.
Yes. So statistical test. So here is your revenue on continuous scale. It was here, and now we have a particular fence where we would say, where statistical hypothesis will say there is no difference, and there is no difference both ways. If the difference is bigger, if it lands here or here, it will say there is a significant difference.
And to translate, to use this 4%, we know that our revenue increased by 10%.
Mm-hmm.
We know it from our example. Statistics shows that.
Well, we hard coded it.
Yeah. Okay, let's imagine it is real life. We know that the plus 10%. On average. And statistics says that significance level is plus 4%. It means that from statistical point of view, we can say that when we will comment the results of the test, we will say that the effect of the reception is plus 6%, correct? Not plus 10, but plus 6.
No, plus 10.
Plus 10, but
we just have no visibility in the particular zone here. We see nothing here, nothing. If small changes, and here we see precisely.
In some ways, it's like it's verifying our decision thresholds of 10%, right?
So once the difference is the effect is more than 4%, we can say precisely that all the difference is made by receptionists.
Yes, and statistically significant. But if the difference is 1 or 2%, it can be by chance.
No.
but we do not know which way. So the more data we gather, the more sensitive we are both ways. And with online trials, a potential trouble is that 9 out of 10 have negative effect. So actually we have much more trials that do not work or have negative effect than they have a positive effect. So we have to do two-sided tests, just in case. Because we never know, at least people who conduct a lot of online trials, they say that very often the design choices or product choices are counterintuitive. First 3 times it's intuitive, after the 3rd time intuition stops working and it's just experiment based. And it can go both ways. That's why we have to be careful with sampling size. For discrete variables, it's slightly simpler. Online calculators work better with discrete variables, with classification, click or not click. For example, booking hour calculator. But here we really need to understand the shape of the curve. What was interesting is that with this approach, for example, what would happen if our effect is 4%? 104. We basically resimulate, with 4% effect on the graph with 10 stores, we see almost nothing visually. I mean, there is some difference. The blue one is on the one blue store or the fitness center is on the left, and few, I don't know which color it is, but anyway, it's on the right. But this is the whole difference, which we cannot assess visually. It's still randomly, well, nothing breaks. So our statistical test starts to fail because we have just 10 samples. They say it's probably the same distribution because when we calculated the 4.3% threshold, we put 30 stores in the trial. So we either expect bigger effect, or we need to put more stores in the trial for a smaller effect.
Searching.
Well, now it doesn't really still make sense much, at least in my case, the histogram. So I cannot really understand if it actually, well, I can edit it because there is almost all blue.
Yeah.
And here is almost no blue. But how significant it is, it's a task not for a human brain. Let's see. It still thinks it's the same distribution. Yeah, it's let's go to a statistical simulation. It will be just faster. So what we do here is we have a base revenue, we have improvement, which we can change, and we have number of repetitions. For each repetition, we regenerate the data set, so we do not run the same mathematics on the same distribution. We regenerate the data sets. In this case, I think I prefer if I put the same scale or a different one. I didn't want to move it into parameters. Yeah, slightly different scales. I didn't put into parameters more things, so I'm just playing directly. But we can move it into parameters of the function. Then I'm doing t-test of independence. I decided to try to leave it. And then if here we know that there is an improvement, it's positive or negative, there is an improvement. So if the probability of rejecting, let me say in the business terms, if we get it's the same distribution but we know it is not, it's a mistake. So we append the mistake to the list. If we know that the probability shifted and we append 0, and then I'm just dividing sum for ones for the list, and this would be a rate, a false negative rate. So on how many trials we will get where we actually have an improvement, but we haven't found it. But keep in mind that this is generated data, so it actually means that our distribution in real life would be, yeah, so now it's 0, 0, 7, because we have big improvement here, and the number of observations are
10, I think.
10. So basically we can regenerate, yeah. So, but if we're aiming at, but this is 007. Now it is 013, because every time we're generating the distribution. But anyway, it's a small number. And when we did the simulation before, we actually knew that the power, change it. We knew when here was 1.1, we were able to detect an effect smaller than 10%. So, what would happen if we would put, sorry, 1.5? We would see, yeah, we would not notice a difference in 50% of the cases.
And that was its improvement 0.05.
Yeah, if it is 5%. So it means that you conducted a test and you lost half of the uplifts, and they are still there with this amount of, with this size of sample. If we improve the sample, 30. That's why there is a magic number, because 10 is on very small limit. Sorry, it's called positives. It still gets to acceptable range. But again, we have 30. And in our case, the statistical power is 4%. Oh, not statistical power, but the effect that we can measure is 4%, and we put in the equation 5%. This is a similar function. By the way, regarding the syntaxes. In Python, if we iterate on something but do not use it in calculations, it's the good practice to denote it with underscore. So I'm iterating by number of repetitions, but I do not use it anywhere in the calculations. So I'm just assigning the underscore. And same here, t-test and the statistical functions return to tuple. It's a data structure with few objects inside. And in this case, I do not care about test statistics, I care only about p. So basically this code says that I do not care, I do not use the first response, there is no name to no point to name it. I'm using only the second one, the second one goes into, that's the guidelines for writing the code. Just more Pythonic way. Same stuff for false positives, except it's different. I'm fixing an improvement to 1, so I know that the distributions supposed to be the same. And when we're getting the response distributions are the same, it's right. When we're saying they're different, it's wrong. That's it. 5% chances with, I think there was 30 here, with 30 stores in the experiment, we're getting false positives.
With this, like, our p-value is also 5%. Is that just?
Yeah, this is exactly where we're aiming. But we can check. Well, this was done to check the influence of the variance, and frankly, with this kind of data, the variance or standard deviation doesn't really change much. We do not see when the test is failing, but since we set the distributions, we actually know independently on the variance that that we can reject or accept the hypothesis. So far, if we, for example, have a variance of, in one case, we have a variance of $5,000 and one $15,000, it would still be more or less, it would work slightly not as good, but 0.05 would be 0.06. So we're just, statistically, it's, strictly speaking, it's worth reject the hypothesis, but it doesn't make much difference in this case. So that's your real-life use case. Well, or almost real-life use case. But in reality, this is an actual use case of the business. Not the fitness centers, not kind of something else, but this, and let's say the following. The effect would be plus minus $1 million a year of the treatment. So an analyst wasn't sure, does the company add $1 million a year in sales or lose? So yeah, that's the way it looks.
So it was the real case, yeah?
Mm-hmm.
And they really proved that...
Because the experiment design was wrong, so they couldn't prove it. They would have to redo the experiment.
What was the mistake that they made in real life?
Hmm?
What was the mistake that they made in real life?
They launched experiments one by one. So, for example, this is store one. The actual mistake was the following. First, it was not random sampling, which theoretically would be fine. We could try to imagine stores which perform similarly, but it would already give us a bias. I'm pretty sure about this. But the second one was, for example, there are few subjects in the trial, and this is time. They rolled out consultants one by one. So first they rolled out here, then they rolled out here, then they rolled out later, and later, and later. So this is one thing. In this case, if we would take a short period of time, for example, we would investigate on other stores that if it would be in one time, we could take a control group, check that there is no seasonality, for example, in between 2 months, hopefully. Then we would be able to do a parity test. Before the treatment, after treatment, with just 1 week of data or 1 month of data, a short period of time. But they shifted it, and our pairs are in different time zones, like shifting months in between. And second, if we are comparing treatment group comparing to non-treatment group. It was not randomly selected, so there is a huge trouble picking the control group. So if we put a nice control group here, results are statistically significant, everything is perfect, but there are a lot of evidences that it's a wrong control group. Which basically, what we just did, even doing it first time with basic knowledge of Python and math, takes roughly 3 hours. So the whole experiment analytics would take 3 hours when you have the data, maybe 5. But the failures on the experiment design stage are rough. So I think it's time for the break.
Coffee time. Reading.
Does it look easy?
All these details, yeah. So you got all these details from your experience, or you read a lot of articles. So.
First, I started with science, and we did some nasty things, not difficult, but wrong things during my PhD. For example, I started to work in the lab when I was 15, and when I came to France, very motivated, and I was given a particular task to reproduce a research of another guy from the same lab. And he gave me kind of frozen chemicals, kind of deep frozen, and a postdoc supervisor. And I was struggling to reproduce the experiment, and this is a big lesson for me. We changed one chemical for the reaction, then we changed another one, then we changed another one. But they are pretty expensive. Kind of 100 milligrams would cost 500 euros. You do not need much for the experiment, but if you throw a vial with a frozen one, which has 100 euros in it, you feel the money, especially when you come from at the middle of 2000s from Ukraine to France. It seems to be a lot of money. So I couldn't reproduce, neither me nor a postdoc, we couldn't reproduce the values. Chief of the lab was pissed off, and actually all chemicals were spoiled. Changing 1 out of 3 did exactly nothing. We had to throw away everything that was frozen before, make a new one, then we could reproduce it. And we spent a lot of efforts picking one by one, kind of what would happen if we change 1, what would happen if we change 2, what would happen if we change 3, instead of throwing everything away. So it starts from experience, painful experience, and the experiments took weeks of time, full time. So you spend roughly 3 weeks full time, 4 weeks full time, and you cannot reproduce anything. And then when you read the papers, you start to notice that everyone is very strict about sampling strategies, experiment design, etc. Very strict.
So it's crucial.
Yeah. You can put binomial data in t-test, and it will be fine. But you cannot really put wrong experiment logic, otherwise nothing will stick.
Yeah, because data is not correct.
Yeah, so decision-driven, decision-based data are mainly about statistics, but there are way more about the rules of preparing the data. Because if we'll substitute one test with another one, it will be not a perfect one. We will lose some power, statistical power, which on the big scale, if we do thousands of experiments, etc., would bite us eventually. But if we do something like this, every decision would be wrong. literally every. That's the difference. Okay. Any questions so far on this?
I do not understand why we increase our bias if we sample the branches not random. For example, the test one. If you know that there is a pool, not pool.
We do not control for confining variables.
I mean, for the pool, not pool, there's a reason that would make a mistake is that in some previous decision, when you're saying, oh, where should we put a pool? Well, let's put a pool in the neighborhood where people have more disposable income. So those people are more susceptible to upsell and so like.
Yeah. For example.
Right, you're already, the pool means things about the market. That's different. So why you chose the pool.
Or for example, if limited use case with massages. If you do swimming, you probably do not need as much massages as you do heavy lifting. So in this sports center, more people would swim, less demand.
After that, I will take a look on the upsales, and I will see that the majority was done for massage.
Yeah, but then there is a lot of hidden logic.
Well, let's imagine that some services linked with the pool.
Yeah, but you do not know that. That's the point.
Yeah, but after the experiment, I will see the upsales, and I will make conclusion.
But then
that the majority was done with pool-driven services.
Right, but that's another test. Fitness centers with pool versus fitness centers without pool.
Yeah, I mean, I guess in the design of this experiment, you really should say, yeah, I will hire you and I want you to push just this one thing everywhere.
Or you compare the one with pool with the one without pool. But for example, yeah, if you have a choice to do random selection of the fitness centers with pool, then it's fine. But yeah, you get your previous decisions to put the pool in the principal place. So usually people different in this fitness centers or these businesses. That's why experiment design. When you get to trickier problems, the experiment design gets tricky. And when experiment design gets tricky, statistics get way more of limits. That's why there is big data and there is small data. Small data is another twist of troubles with data. You hire a biased statistician who can make a reputable outcome of the study with 20 trials. Like in medicine, for example, when you try to check if some medicine cures cancer, and it costs you millions.
Yeah, so what to do? We have one location.
Then
Open another one.
Yes, I want to know if I should hire a secretary. First, I must open 99 other gyms and then randomly select 10.
Your tests are not on business level, but on user level, on visitor level. You split your visitor in groups, and then make different things.
Mm-hmm.
And then it's not 10 businesses, but 100 and 100 visitors.
So your receptionist should speak to every second. So I will not speak with you. I don't
or by day of the week, I guess we could do it.
Yeah.
Unless it's biased because different. Okay. No.
Oh, that's where you have you do different day of the week all the time. All the Mondays, all the Tuesdays.
So let's do 10 minutes and start at 10 minutes. So just a small recap. We have to always have a hypothesis before, and these experimental design principles are even more important in layman's perspective than the statistical methods we're applying. So for me, decision based on data is more of the habit or a set of rules that kind of precision of thinking. What are the presuppositions, how was the data distributed, how it was gathered, is everything okay, how does it look, etc. In many cases, checking the graphical representation of the data is enough. It's difficult to prove to top management or CEO or the owner if they do not have the same mindset, but still decision based on data has many flavors. So we have finished this use case. We went through it. Yeah, I would like you to repeat partially repeat, but with very different data. A retention, 6 months retention. Kenneth, what is the theoretical value of the 6 months retention?
Like in dollars?
No, retention in percent, for example.
Like middle 70s%.
So that would be one less.
No, it's actually 70, middle 70s.
Okay.
That's because the precise model is monthly recurring billing.
So it's difficult to jump off.
But no, it's not difficult. But
Well,
just,
it requires an extra.
there's an action, right?
Okay. Let it be 70%. What would be the standard deviation in between different
Quite
or
wide.
people?
It's quite pretty wide.
Or well, we can do same, but yeah, let's modify a bit. I know how to make it more interesting for you. Or hopefully more interesting. Let's say we have one business, not 100 businesses. One business, one fitness center, let's say 2,000 clients, and we changed a particular treatment. For example, we started to call some of them and try to make them come back or not to cancel their subscription. Yeah, subscription. For example, we are making so for example, we make RFM or recency frequency, we do not need monetary value here, and when we see that the person has not appeared in the gym for, let's say, 3 weeks, but they still have a subscription, we send them a discount for subscription for the next months. For example, I don't know, 10% discount. So we lose a bit of money, but we simulate, we incentivize people to continue to renew a subscription and not to see that they are paying X time in the row, X months in the row and not going to the gym.
The precise thing we do is we send them a free pass to bring a friend if they haven't shown up for a certain period of time. That's specifically what we do.
Mm-hmm.
Another, we can send a snapshot of a fat person after finish.
God of marketing. Well, you can do that and do A/B testing as well. And so what happens. So, let's calculate. Well, we have to send an incentive because probably do you have instructors in your climbing pool?
Yeah.
But basically, it's one instructor per one visitor, or it's
No, it's like a swimming pool.
it's like a swimming pool. So basically, you have to come in pairs,
Yes.
or to meet someone alone, but it's unpredictable.
Yes.
So basically, you have bring a friend, increases the incentivize. Let's say it's non-climbing gym, personal trainings. The person comes to the personal trainings or group trainings, and then it suddenly stops. So we introduce a particular treatment, which is a marketing effort. And our goal is 6 months retention rate. Can you design a trial and go through your ideas about a standard deviation and the distribution of the 6 months retention rate in one fitness center? So you have to come up with a setting, experiment setting, amount of population, etc., 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 amount of visitors who are taking part in the experiment. How would you pick them? Well, in this case it's obvious. It's probably an email for those who are not returning, and all the statistics needed to prove hypothesis, and what would be a statistical power of the test, which minimal effect in terms of retention you will notice with a particular setting. It might take you 10-15 minutes probably. Especially if you have a notebook. If you will have any questions, ping me. I'm here. You do not need to stay with your laptops alone. Well, if you have any questions about the approach, etc., even if I was telling the same thing 20 minutes ago, do not hesitate to ask me. Because I'm pretty sure you will not repeat the same exercise at home. And here I would encourage you, or it will be
So, how is it that we would characterize a 6 month retention rate?
either in percent or in monetary.
I guess monetary is what we use this way of doing it. So, like a revenue of a certain amount of money, 6 months times the monthly something.
Yeah, but
Percentage.
if the person cancelled an NRA period, for example, if the person paused
Yeah.
membership for a month, or churned, left for a month and then came back, is it a same? Is it a part of 6 months revenue, kind of retention revenue, or it's a new buyer now?
I think that the way that it's the standard way that's calculated is that what's the percentage chance that somebody has a membership 6 months after initial purchase? I don't think it pays attention to what happens in between.
In cohort analysis, it does actually. Because in cohort analysis, it's the homework from the first day. Because generally, this is exactly the way to measure the retention rate. You just have a cohort of users which churn months to months. But as far as I recall, anyway, pick any metric. It doesn't really matter how you calculate it. So the one that if the person still appears in 6 months, it means everything is fine. I think most of them, when they go, they do not come back in a month.
I think
if they go, they go.
That's my instinct as well. I think there should be very little noise from people stopping and starting again.
By the way, there is the same stuff with hairdressers. You have to go to a barber shop every X days or months, unless you do a major change. For example, you cut the hairs 3 times. So, for example, every 2 months instead of monthly recurrent membership, you have, for example, few months. If someone hasn't come back in 2 months, it means that he's either changing something or went to another place.
No, but reality is a bit different, not 1 month, but closer to 2.5.
Yeah, well, I was saying 2 months probably. Well, yes.
Really? That's the space. Is it space?
There are a lot, average. A lot of customers work monthly, but there are also significant part who comes every 2 months or 3 months.
I guess that's when.
Mainly women, of course.
So you can calculate churn rates for
For this A/B testing, let's imagine if you speak about contacting of potentially churn people. So if we take 100 people list, we make something for 50 people, and we do not make something for another 50 people.
Yeah.
So it seems like A/B test. But in fact, among those 50 people with whom we contacted, only 10 reacted. So what we should put? This 10. This is this percentage. We should convert this in this percentage. Not in this one, but.
Actually, when you have a pre-selection process of people where you're sending messages, you are diluting your samples. So there are 2 ways. You are either diluting your sample. For example, you have 200 people, but in this period of time, only 30 people are intending to churn. So we're sending only 30 messages, and if they are randomly distributed in different groups, then in the same group, again, those more or less 30 people are intending to churn. Or we're saying that we do not care about the diluting part. We select, I don't know, X people from group 1 who are intending to churn and do an action, and X people on the group 2 and do not do an action. Because churn models, they are highly not really precise. Those people still, a lot of people from those groups will come back. The classification power is not stellar.
So would it be just say, okay, I'll just, after 6 weeks, after you buy your first membership, we will send everybody an email saying something, and then
Or no one.
after 6 weeks, you take all of the people, divide them in half, send half of them an email, don't send half an email, and just compare drop-off rates of those two groups? Like, don't bother trying to find who might be.
Yeah, this is without segmentation. This
Yeah.
is this is actually also a real use case in a pretty big business that I've seen. So this. You have few options, and which option you would select, it's up to you. But basically, you have the whole user base. Let's assume that the user base is what we do not do random sampling. We'll just, for the simplicity, we just cut the whole user base. We either do a test with communication or without. But this communication also costs money. Email do not, but incentives does. For example, if I'm planning to come next month anyway and I'm ready to pay and I'm offered an incentive, I'm saying, well, of course, yes, I will just pay less. Then there is another then we can add a technology plus churn predictor. Which can be from deterministic, like recency frequency, to survival models, to classification on neural networks, whatever. This would work if you have a good data set and good historical history. This would work better than recency frequency. But recency frequency is 1 hour to implement, and you do not really need a data set for that. So you pick one of those. It doesn't matter which one, but it has to be consistent. And then you can put, if you add churn predictor, you're getting into a situation where you have your user bases. Then this is probabilistic methods in general. If we think that the person is going to churn, it doesn't guarantee that the person will churn. So this one, we do nothing. And this one are in danger of being in churn. For one, we do nothing. For another one, we send an incentive. And we can do comparison of the whole group with the whole group, or subgroup with the subgroup. Here we do the data, here we don't. And then, theoretically, if you are a data-driven organization, you will see a particular uplift. You will see the costs associated with sending, in your case, the costs are minimal.
Yeah.
In some cases, the costs are not minimal, because it's not only about the cost of the marketing effort, but it's also the discount, the loss of the revenue, etc., etc., etc. So there is a benefit and the loss associated with this, but we, for example, use the first method, and then we see the uplift. Then we can do another experiment later. We implement better model, and we split the populations. In one case, we pick those who churn with old method, for example, recency frequency, versus neural network. And for example, if marketing efforts cost money, we fix the budgets here, plus budget, or we do an estimation that we will talk tomorrow about the effect of the model on revenue or on a particular metric. And this is again an A/B test. Then you're testing same marketing effort, but better selection of those who churn. Because
you're not interested in validating the churn prediction at all? You know, like, how do you validate the churn prediction?
This way, we have an action. If
perhaps we should,
separately.
Yeah.
We can. There are again. It's more about tomorrow, but there are at least three ways to validate churn prediction. First, you have, in case of recency frequency, there is no validation. It's deterministic method. You just group by and you use it.
With sending some emails to the people who were not predicted as churn, vulnerable to churn, would that validate help develop churn prediction, you know?
We do not know how they would behave. So if we are checking the churn, we basically have to wait and see how they live. If they live, then we're right. We predicted and they left. We have predicted and they haven't. Then it's not.
And will this find negative effects as well? I guess it will.
It will.
Yeah.
For example, in your case, it might not be much of a negative effect because bring a friend. This just have more.
But his suggestion.
But for you, it's someone will get 10, 20, 30% less money. Even though if I'm planning to come just a week later, I'll gladly come a week later, but with a discount.
No, I meant his suggestion of sending the picture of a fat person.
Yeah.
That might not be a good.
So it might have negative effects. The first and very straightforward things probably will not have them. But when you will add finances into the game and you have costs of your efforts, things would happen. So basically, about churn prediction model, we will have this situation. We have, again, people, let's say 2 groups. On the group without the model, people who churn are distributed somehow, let's say evenly. Model which makes churn prediction is supposed to make higher concentrations of people who churn and live in another space who do not. There will be still people who churn. So the only way to test is one on historical data where we trained it. In real life, by tracking, we predicted the churn, but didn't do any efforts, and they actually left. And then there is another way, which we will talk more in details tomorrow, is comparing distributions of classification. It's more of the health of the model. It's not very precise check, but it works for inline models immediately after they deploy it into production. But it's very weak from the business perspective. It's just instant feedback to the data scientist, but for the business it has no value. So for churn, you have to, and then if you check the efforts, for example, you take the same data set, you build 2 models, weak and good one, like linear regression and neural network, and you benchmark it kind of weak model, strong model. If you know that your efforts actually work with joint people, then you measure, well, in this case, you lose a bit of revenue, because your classification is imperfect, you lose a bit of revenue, you have a hit here. The more people, the weaker model, the bigger loss of the money loss you have here. So in this case, you have to take into the test the whole group, because here you have loss, and here you have gain. If big amounts of people are churning, if you have a churn of 0.5%, probably you're already a billionaire, or selling drugs. It's either or. But then you need to have insanely big test groups because the amount of people who churn is very small. But generally, normal businesses have much higher churn rates, so we still dilute the data, but we can see which kind of losses our efforts how cannibalize people who are able to pay full price to people who has gotten incentive and haven't paid the full price. So it's a particular kind of cannibalization. And in long term, it might have a negative effect because if person is used to discounts all the time, and then we update the algorithm, and then he is or she is not getting discounts, they might churn. And this is exactly why we cannot predict anything and we need to test.
But
Literally.
if you put in place this system, so in I think, and if this information, I mean, the churn prediction is useful for the business.
Usually it is.
Yes, let's imagine business starts to contact customers. The churn, we see that the churn rate is decreasing. But here we should immediately change our model. We should take into account all the messages we send to customers. Otherwise, we cannot improve our model.
What do you mean take into account?
Well, how you're finding
Did we
the
try?
churn risk people.
Yeah. So
So
the
they're
data
not experiencing a different business.
Did we try to stop them? Yes. What we did?
we send a message, so it's the
Which kind of message?
That's
Maybe we should send another message. So this is the improvement for me. The next step will be for me the improvement of the
churn model.
churn model. Yes, taking into account the contacts with the customer.
So in online advertisement, a typical traffic split is the following: 10% of the data is randomly bidded and 10% of the bids, and it's used to train models. So you train the models that you apply to other data. So you always leave a fresh data set. In case of online ads, things may change pretty rapidly. So in many companies, there is a daily update of the models, and sometimes it's considered relatively slow. But in my perspective, daily is more than enough. But still, every day you take this 10% of bids, you retrain the model, you roll into production back, and then you serve 90% of the traffic today on the history that you generated yesterday. For the business, you still have, if you want to improve a churn model and remove the influence of the interactions which you already put, you need to have a holdout group, which you actually find if they're living. And then another task, calculate the number of holdout group, because it is actually the same mathematics of the power, same statistics involved in calculating the size of holdout group.
Is there another they have to be a magic number sample size?
It's not magic. It's calculatable in terms of, because 10% here it's a huge traffic. It's those big data companies which don't exist in Ukraine. This is there is one Ukrainian startup or startup, decent company, or actually few, and there is an office of the British startup of 200 people working on this topic. So 10% is actually 30 million rows or 50 million rows, easily, or even bigger amount. But if you have 2,000 people, what would be a representative portion of people to let them churn, to improve your churn model? Well, this is a question for you as well. You can find the answer here, because it's also kind of an A/B test. Because you have the whole population. What is a minimal group with which comparing to? So there is a treatment group and there is a control group. How big should be a control group to see a particular uplift that is statistically significant in treatment? For example, we expect that our churn predictor gives us a chance to earn 5% more money. Kind of, we are fine with not noticing the 5% difference, because we believe our churn model is super strong. It will give us 50%, so we can do it 5% increments. So what would be the sample size of the test where treatment has 5% better revenue, and control has, yeah, it's plus 5%, and our churn is, let's say we have churn rate of 30%, and here it starts to be 25. What is the minimal sample size? That's the way you calculate your holdout data set, statistically significant. Same, exactly the same.
Okay. Now we're targeting retention rate.
Yeah, let's go back to the retention rate. But the discussion was good, I think. By the way, while we were discussing, did someone finish the task? By the way, what we just discussed is actually the reason why I'm making you doing it by yourself. Because same approach from a different perspective is exactly the answer on many questions. How many people do we need to train a model? How many people we need to test the model, etc. It's exactly the same principles.
negative number for the stat one?
Your standard, 3 standard deviations, maybe you have a big standard deviation.
I'm calling retention rates 74 and the
Standard deviation is
5.
then you shouldn't have negatives.
Yeah. I'm sure what. T-test. Stat -21. P of 0.
But this is fine. This is fine. So every statistical test returns their own statistic, which is their value that you have to cross-reference in the tables, and p-value of the hypothesis. Software packages cross-reference the value for you, and they still return it.
So the -21 is irrelevant.
-21 is internal statistic of the matrix. If you will change the type of the matrix, it will be not -21, it can be +5, and it still means the same for the hypothesis.
So I exclusively care about the p-value.
Unless you want to dig deeper into the how it works.
So a p-value of 0 is pretty good.
P-value of 0 means that it's
Guaranteed.
yeah.
3 zeros. Yeah.
But it also means that you're expecting big changes of retention rate, and you will not notice the small ones.
I'm calling 10%.
Which is a lot. And you will not notice 10% decrease. I mean, if you will recalculate power, maybe your size kind of experiment setting would allow you to see not 10% but 5% changes.
Yeah. So is there a way to generate non-normal distributions easily? Because I know for a fact that the distribution is like it's super one-sided, right?
We will do it.
Yeah. Okay.
Just in this task, we will substitute in your code another distribution, and what you are saying looks like log normal distribution, at least by the shape. But you have to put it visually in the proper numbers, because in the log normal distribution there is logarithm. And you have to, instead of normal, to write log normal, and we'll do it, or you'll do it anyway. Finish this, and then we'll switch to the normal distribution. That's exactly what I've planned for you. Check how it works with net distributions.
Let's do the false negative, false positive.
Well, isolation, you can, basically it confirms, especially with normal distribution, that everything looks right. I would concentrate more, well, you should do it definitely, but and what is statistical power, kind of, what is the actual limit?
1.6. 1.6.
Really? So you can notice the difference of 1.6. Because it is on, what is the sample size?
400.
That makes the difference. And now, so how is the progress from other people?
Not good.
Not good? You can call me if you need.
Not clear from which point to start actually. From revenue. To start from 6 months revenue.
Смотри, 6 months revenue у тебя это уже параметр. Считаешь, что ты знаешь, как его как считать. То есть, у тебя, грубо говоря, ты его можешь посчитать через 6 месяцев после начала эксперимента. Если ты равняешь или в процентах, ну там не важно, если у тебя чек одинаковый, то ты просто процент умножаешь. То есть, или, только revenue у тебя, смотри, как получается, первый месяц 100% людей платят деньги, второй месяц у тебя деньги платят 80%, третий месяц 70%, но не суть важно, важно то, что предположим, есть финансовая документация, и у тебя 6 months revenue это конкретная цифра. Вот, то есть конкретная цифра это не какая-то табличка, и ты просто тот бизнес-кейс, который ты прикидываешь, финанс-центр или свой бизнес, неважно, ты должен просто его внести одной цифрой. Но это полбеды, важно еще прикинуть, насколько она варьируется между разными клиентами. То есть если вот, все клиенты по линейку ходят,
Наши могут новые клиенты приходить, уходить. Во втором месяце могут зайти.
Это другой город. У них 6 months retention rate будет еще через месяц. То есть только существующим клиентам ты можешь взять 6 месяцев. То есть ты можешь посчитать 6 months revenue только для тех, кто уже на борту. Это как...
То есть, грубо говоря, мы считаем назад на 6 месяцев, да? То есть фиксируем, какие клиенты были 6 месяцев назад, смотрим.
Это если задним числом. А если мы сейчас запускаем... Нет, если мы хотим коммуницировать...
Мы прогнозировать хотим, да? То есть...
Если мы хотим с ними коммуницировать, чтобы в реальной жизни проверить, то нам нужно сейчас коммуницировать. Мы берем 2 группы. Через 6 месяцев мы получим цифру.
То есть это, в принципе, прогнозирование хотим делать. Это задача просто прогнозировать, или что?
Нет, у нас задача понять, как, вот, например, ты бизнес.
То есть дескриптив это статистика, или это как ее, которая из сэмпла
нам нужно спрогнозировать, как провести эксперимент, если мы начинаем его завтра. Результат ты получишь через 6 месяцев. Но сколько тебе нужно людей, в какую выборку добавить? То есть завтра мы можем присылать скидки тем, кто хочет уйти. Завтрашнего дня. Как это повлияет, как нам нужно организовать измерения, чтобы через 6 месяцев нам стало понятно, мы этим способом зарабатываем деньги или теряем. Ну, у нас метрика 6 месяцев меняется.
Хорошо, еще мы должны начать.
Мы должны начать с гипотезы, какой у нас, сколько мы денег, какой у нас, грубо говоря, сейчас churn rate или какой у нас 6-месячное revenue. Потом мы должны сказать, я думаю, что на пару процентов это должно помочь. А потом
на нашем там, ну, нулевая гипотеза, потому что не меняется.
то, что есть сейчас, правильно.
Да, и альтернативная.
Да, насколько ты готов, ну,
на увеличиться на 2%.
например, да. 2%. И тебе нужно посмотреть в текущий, или сейчас в этом случае придумать, какое стандартное распределение, потому что оно влияет. Если у тебя у всех одинаковый,
Ну, по сути, там надо вычислить n, да, то есть количество сэмплов. То есть надо пройти эту задачу, то есть обратная, то есть надо выйти на количество сэмплов.
Да. Ну, то есть, если ты планируешь эффект, ты приходишь на n, или ты говоришь, фиг с ним, я планирую эффект гигантский, считаешь, что он статистически достоверный, а потом добавляешь формулу предпоследнюю, которая стимулирует. Я говорю, что слушай, с такими параметрами распределения и так далее, ты на самом деле заметишь не 10%, а 3%.
Хорошо, вот N, да, то есть это то, что мы, как толка, мы собираемся advertising компанию, да, какой-то скидки предложить или еще что-то.
Да. Тебе нужно понять, к какому объему.
Да, ну это же также у нас есть тут же вопрос, это инвестиции, это затраты, да, наши на эту компанию.
Верно. И тогда у тебя есть, получается, затраты и потенциальная прибыль, которую ты хочешь. Стоит их рассечь, если retention увеличится на 2%.
Все-таки мы должны, скажем так, плюс 2%, плюс мы еще должны заложить.
Минус затраты.
Да, затраты должны заложить, да.
И ты смотришь, потом ты говоришь, что затраты не не готовы столько платить ради плюс 2%. А в плюс 10 ты веришь? Если веришь, вперед.
Мы должны на количество, то есть выйти на n, да, то есть.
Да. И то есть это жонглирование несколькими шариками. Тебя интересует количество людей, тебя интересует тот эффект, который ты можешь померить, и те затраты, которые ты потратишь ради достижения этого эффекта. Чем это просто? Приходите бесплатно один раз с другом, по большому счету зал ничего не стоит, если зал не всегда загружен на 100%. Так оно, скорее всего, и есть. Соответственно, там просто кост. Единственное, он теряет, если это можно использовать для не-мемберов, но скорее всего, для мемберов. Это, скорее всего, не так, поэтому он почти ничего не теряет. Разве что человек бы пришел и купил подписку, а так он один раз пришел бесплатно.
По сути, это вот этот сайт. По сути, это
проще всего
вот этот вот сайт, да, то есть, который мы смотрели, то есть это можно что-то делать конфигурацию.
Это с номером, да, это то же самое.
Вот же сам size, да,
да, только у тебя было 50. Standard deviation тебе нужно понять, какая, например, да? 50%. Через 6 месяцев у тебя осталось 50 человек. Добавилось шумишка, мне он с непрерывными величинами не нравится. А вот так нормально.
То есть это был churn rate 50 у нас, да, то есть мы ожидаем
плюс-минус 5.
Ну, минус 5 ожидаем, да.
Ну, мы надеемся минус 5, но мы проверяем в две стороны, потому что-то не так натворим. Да, значит, соответственно...
Какие-то абстрактные такие понятия?
Нет, плюс-минус 5 это не изменение. Плюс-минус 5 это что у нас сейчас churn rate в среднем от 45 до 50%. Он же непрерывная величина. Мы, например, берем 1000 человек или 100 человек. Он же не у всех одинаковый. Кто-то ушел раньше, кто-то ушел позже, кто-то остался.
Ну, это сам range.
Да, это вот standard deviation, которых 3 в одну сторону, 3 в другие, покрывает 99% кривого. Вот, а дальше мы говорим, окей, мы надеемся, что он изменится на 5 абсолютных процентов.
То есть минус 5, потому что...
Нет, тут 5 это двухсторонний тест, потому что минус 5 или плюс 5. Мне не нравится, как он считает.
Что 36 в таком случае значит, что у нас уменьшился...
Это значит, что у тебя должно прийти остаться на 36 людей доль больше. Это значит, что твой бизнес выиграл, ну, это именно для онлайн-теста. Интерфейс для АБ-теста в питоне точнее посчитать. Но если мы приводим это к АБ-тестам, это значит, что у 36 людей
Так чем вообще отличается АБ-тест от Python? Это же просто инструмент, а метод
Здесь используют use case с кликами и временем на сайте.
Здесь какой-то определенный там статистику какую-то или что?
Здесь такая же статистика, просто он заточен на вот эти вот цифры.
Да, то есть параметры.
Под время на сайте, например. Потому что Total New Visitors это вообще вот, например, биномиальная метрика, у тебя была конверсия 5, стала 4,5 или 5,5, ты это должен показать 60 тысячам людей, да, 60 тысячам людей, чтобы убедиться, есть у тебя прирост концерта или нет.
Ну хорошо, если мы тогда переключимся к Python, да. То есть здесь что надо начать? То есть...
Ты можешь начать с двух сторон. Самое простое, ты просто говоришь, предположим, у меня будет рост на 5%.
Да, то есть...
Вкидываешь размер выборки, который тебе не жалко вначале. Доходишь до конца, можешь помогать. Доходишь ниже, еще ниже. Выше, вот сюда. А здесь у тебя есть решалка. На самом деле ты ее можешь только использовать.
То есть вот это имеется в виду ожидаемо на 10% увеличения, да?
Да, смотри, вот у тебя было...
Это затраты?
Нет, это было ставка.
А, было стало дифференция. Да.
Смотри, например, у тебя было 50. 50.
Может,
Ты ожидаешь, что станет 55.
может, наоборот, или
Ну,
абсолютно?
Не знаю. Смотри, ты думал 50, станет 55, и твой standard deviation там, например, 5. То есть standard deviation 5 это значит, что колебается от 35 до... Ну, короче, колебается, но в общем. Дальше мы берем...
Колебается, что churn rate?
Да, потому что это же между разными людьми. Что, поздравляем? Поздравляем.
Churn rate между разными людьми.
Заново просто почти.
Вероятность?
Предыдущие пересчитать.
Не, здесь посчиталось. Он base revenue использует. У нас base revenue нету, у нас вместо base revenue 50 было.
Там же много. По сути, мы просто на статистике в ту сторону делали, это обратная задача.
Да, то есть по большому счету, да, ты пересчитываешь M, и ты ставишь, сколько ты хочешь.
Confidence level,
Да, как ты готов потерять, какой тест ты делаешь, сколько у тебя людей в эксперименте.
Разве альфа-пауэр я уже забыл, они не...
Они на друга не влияют. Это...
Я помню от Power, что такое.
Power это значит, что у тебя есть 10 удачных гипотез, которые явно приносят деньги. Но твой тест скажет, что удачных 9 из них.
Это не confidence level, это же альфа.
Да. Ну это один минус альфа.
Нет. Ну, это 1 минус 2, потому что это two-tail тест. Тогда не получается, все-таки они занимают.
Не, это false positive, это false negative. Positive это вот ты...
Смотрите, просто здесь вот 0,9 плюс 2 тейла. Тут просто...
да, 1 минус 1.
Да. Как вот оно шагает, оно же зависит от первого, я не могу сказать.
Нет.
По сути, power в данном случае это единица минус 2 поста.
Power это единица минус false positive rate. False negative rate. Вот это false positive rate, это false negative rate.
Вот я не помню, что мы power по статистике использовали.
Не, Power, конечно, мы не используем.
Альфис использовали.
Просто, может быть, она называлась по-другому, типа confidential level. Но мы, честно говоря, сама A/B-тестинг особо не... Классификацию мы там слабо выполняем.
Have you tried a log normal distribution,
No, I did
which
not.
visually looked? What is power? Power is the probability of rejecting the null hypothesis, when in fact it's false.
То есть, понимаешь, это единица минус пи.
What mathematical power is 1 minus beta.
Что?
В этом
What power is the probability of avoiding type 2 error. А там type 1 error. То есть, по большому счету, тебе нужно вот этот симулятор, тебе не нужно включить АБ-тест, тебе нужно взять симулятор и понять, какой эффект ты заметишь достоверно. А потом посчитать, сколько денег нужно для достижения этого эффекта и понять, что это хорошо. Have you seen the log normal?
How do you do that? Just log normal?
Log normal. Better first type in Google find log
Yes.
normal.
Okay.
It will generate you log normal, but it will generate in a weird sense.
Normal. Right?
Yeah. It will put you to a random packaging. Yeah. So check this one. The values would be very different. So log normal starts.
Your sigma.
Yeah, it's the mu and sigma, but you have to put the values so it doesn't start from 1. For example, you do log normal and then add shift by x, 70, for example. Or you do, so you have to manually make something which is log normal plus shift or a particular kind of log normal. Let me check.
What's mu and sigma mean here?
This is same as median and standard deviation, but in log normal distribution you have a logarithm on top. So you have to doctor a visually appealing for you distribution, which is not normal, but made by, let's say, log normal plus shift. So you do log normal from 1, like you're copy pasting from random log normal. Where is it? For example. Where is my unapproved though?
So,
For those who have finished, you can try to put another distribution instead of normal and see how it performs. Mhm. look, does this I will shift the, yeah. It starts from 55. Well, this is 55. Does it look like
55 what?
this is 55, this is 70. Does it look like the distribution you wanted to get?
Yeah, sure.
More or less.
More or less.
So look, basically what I've done is I take log normal, which and then shifted it by 50.
Okay. And do the same thing for the treatment things. And so you'd add what?
Well, you can shift it more not by 50 but by 55. So this is your skewed distribution, which is the same, but you shift it. To make it harder for the system, you can change the coefficient. For example, to make longer tail. But now we are using statistics for normal distribution, and there are statistics which are in the same table for entirely skewed distribution. They do not compare means, they compare kind of a fraction in the long tail, which is in this big table which split the methods, one line lower the one with means. It's just trickier to understand in general because this is not the mean. Like we earn on average $70 per month, and this is like the distribution shifted somewhere.
Yeah.
But it actually shows what we have to do.
I wonder what the real thing to measure would be. I wonder what the real thing to measure would be.
Yeah. Ну что? Прояснилось?
Ну, хорошо, то есть
То есть можно делать несколькими шариками.
понятно,
А и в этом расчете еще нет стоимости проведения эксперимента, стоимости разработки технологий и так далее.
да, там или, то есть она есть, вы говорите, что ее там она минимальная какая-то, да, то есть.
Да, там где она минимальная, это проще вариант, а если ты говоришь, типа я ожидаю прироста на 1%, для этого мне нужно вложить там $100 000 в технологии. И там каждый месяц платить еще 10 тысяч за еще что-то. Тогда можно считать, имеет ли смысл. Вот effect size это mean difference между... Это t-тест, то есть t-тест показывает разницу между вершинами распределения.
Да, да.
Это значит было, стало поделить на стандартное распределение. Если ты хочешь наоборот, тебе нужно умножить на стандартное распределение, это будет твой эффект, который ты заметил прямо. Или в деньгах, или в процентах.
So,
А там я поломал балансат назад, когда все можно.
0,2%, мне вообще ничего не понятно.
А сколько у тебя там между?
50-55.
Standard deviation 5. И на 10 людях. Что сильно хорошо. А, еще нужно умножить на 100.
Почему?
Это же процент слышал было.
it's almost like the rest of the rate is from what distribution
Это я добавил процент. Тут еще было 100-500. Там где кома, надо было умножить на 100. Почему? Потому что у тебя мало людей было.
Has anybody ever tried membership models for haircutting? Somewhere?
Там membership. А смотри,
Да.
давай посмотрим.
We'll
У
just
тебя
pay
есть
so much a month.
mean diff.
Come in and get whatever services.
Standard deviation, значит, мы получаем size.
No?
Вот нам его нужно умножить на
Can't
standard
think
deviation.
imagine would work for men.
Это будет
Amen.
min div в абсолютных единицах.
Like
В
for
абсолютных единицах.
$40 a month, as many haircuts as you want.
Снова убрать. Вот абсолютные единицы.
Это тоже брать.
Ну, можешь убрать, да, законно.
You don't have to make an appointment. Just walk in,
Больше.
with your head, you walk out.
Ender file. Раунд еще нужно посмотреть.
I need to get my beard cut.
Ты можешь что надо сделать.
It's getting away
Видишь,
from me.
говоришь, если округлить, то ты увидишь эффект.
Should be-
Увеличить, это будет значительно.
On average, should be slightly, the price should be slightly higher than.
Еще раз.
No, lower. Lower than the cost. The idea is that more
Нет,
commitment
эффект
from
совершенно очень маленький.
because he goes to Egypt on holiday.
Или
Otherwise, why would you do it? Why would you buy it?
Нет, да, вместе все
Yeah,
зайти.
But also from,
Пройтись все вместе по тому, на чем мы немножко застряли.
Да, можно.
are there a lot of gift cards here? Is gift cards a big thing? We should store some gift cards. Because
Да, сейчас тогда сделаем.
it's a physical store, also it's a gift card.
Physical and online.
Because retention or like redemption rates on gift cards are
Сейчас сделаем это вместе.
it's nuts. How many go?
Yeah, that's the story. It's not
Um,
really good stuff.
Well, people just don't use them for whatever reason.
In one
Again,
in 1 minute we will do yeah, well, let's do it now. Share the screen. So how it was skewed data?
I abandoned hope, so I didn't continue with it.
It happens.
But and then I needed to then look up how to do other tests, and I started to.
Yeah, well, you can just put it with one instead of one of the distributions or most of the distributions at the beginning. You need to change first 2 lines of the code in the simulation.
Yeah, no, but then to do the actual the tests for whether they're major difference, I was looking for tests for non-normal distributions.
This one looks like normal, so the t-test and
It
the
all
test
would
that I
work.
selected, it didn't?
You know, I didn't do it. I just started looking for other
But
tests
it,
because you mentioned that there was other tests for.
it is also already here as well.
Yeah.
It's in the tutorial also. Yeah, so here where we stuck a bit with this simulation. So let's assume the following. This is what I was trying to explain. So basically when you are jumping into the business project, you have costs, including costs of implementation.
So, are we back to the
Yeah.
original?
Yeah, this is original. This is just the part for the simulation. Marketing, etc. Support. There are many things that can go theoretically wrong. But you are expecting to implement a technology that will give you some uplift. Some uplift means you expect a gain in some parameters which is directly or indirectly tied to your revenue, for example. So we're expecting a gain. So how can we check it? For example, we are making a test. So we have 1,000 pieces, 1,000 pieces in the group. So theoretically, we can calculate, we can get an effect size of 0.14 with a t-test. And t-test actually means that we are measuring the distance in between mean and medians of two values which are distributed, each of them distributed normally. So basically, the power of our test, the effect, not statistical power, but the effect, our test is able to measure this kind of effect. What means this? I know why it was 0, because the rounding broke. So what means effect size? If we want to transform it into money or percentage, etc., we have to add, well, not add, but we have to take into account standard deviation. For example, if it was 50% and standard deviation was 5%, which would mean that our effect size divided on standard deviation and multiplied on what we were, from what start we started. So we had 50%, for example, retention rate in percents. Our standard deviation is 5%, so it is plus minus 3 sigma. It's the way it fluctuates. So this kind of test.
Need to rerun on about
It's the old one. Would be able to see differences which are bigger than 1.5%. So, for example,
Is it correct that multiplied by 100 in your case? Because percent. Okay.
Yeah, because it's in percent, and otherwise it's a fraction of revenue, or revenue fraction of the metric, and then it gets to the following: your costs have to be smaller than multiplier, whatever it is. Whatever we have got, gain multiplied on effect. No, not on the effect, but on the base rate. Base rate. Basically, it's the question: are you willing to pay the costs for improving your target metrics by more than 1.1%. The extra hidden part that you will not notice the difference of 1%, even if it will be minus 1%. This is the cost of experiment. If you want to notice even smaller changes, you have to increase the size of the group. So when we're talking about technological solution, the trick is that implementing the solution is usually high. If it's just sending emails like, hey, do not forget us, this is very simple. And it costs almost nothing. So you just do segmentation or whatever, send emails, calculate the gain. But if we're talking about recommender systems, etc., you have to get the data, get the models, run it, etc. So there is bigger overhead. So big technological companies, even when they do not call them technology companies, they have same overhead for the test and for the production. Because you implement the solution, almost full scale, except the thorough monitoring probably. You run it in A/B test. If A/B test is successful, you add monitoring and you push it to production. So it doesn't really save the development cost, and it doesn't decrease the experimentation costs. But at the beginning of the life cycle of the business, the experimentation costs are low. We need just to send emails like, hey, do you remember we have a birthday next week or whatever, or free coffee in our gym next week. And nothing else, and we can already measure the outcomes.
How do we know that it actually will help?
We measure. We have to. That's the point. In decision-driven.
This is a standard deviation. Tell us that.
I know the statistical test tells us that if there will be a difference in real life, we will see it.
No, I think you can send different, yeah. So, as are you getting fed? Yeah. Or,
That's why.
so which will be, you understand? So it's just not to make some action, it's also about
The
the
context, yes,
quality
of the action, etc. You're right. And for example, in booking in experimental teams, there are copywriters inside the team and a designer. So they are benchmarking a particular type of the message.
What's the Python function for that?
so
Copywriting?
Copywriting.
so they have some kind of also, let's say, statistics, yeah, which what helps, what doesn't help.
Yes. Yeah.
But
For example,
we assume that they selected the right tool, yeah, the right message, yeah.
yes. So we can
Yes,
compare
actually.
message to message,
Yeah.
or no message to any message, then previous message to a new message, etc. And all of these are experiments. In some cases, we do not need to do it because we project a small gain and there is just overhead of sitting and calculating. But on the scale of 3 million visitors a day, even copywriting changes the financial results of it.
There's super mature products that do that. Like there's the emailing product we use. It sends out small test batches and checks for things, and you'll then send after doing the testing. Like it's all built in.
Yeah, but it should be some kind of taking into account conversion rate of this tool, yeah. So because as I said, so it depends. Yeah. So what will be in the email?
Yeah, so that implementation matters. This is just the way to compare. So this gives you understanding that whatever 1,000 people is enough to compare with a particular quality of comparison. And now you have to decide what you are comparing.
Okay, so here we are determining which shall be, let's say, minimum number of people, yeah, to check if it works or it doesn't work.
To make a valid decision.
Valid decision. But we don't know whether it helps or not, but we at least know the minimum number, let's say, which
Exactly.
will provide us statistically significant confidence, yeah.
And we also put the probabilities of different kind of errors into the picture.
Yeah, but we would use this exact same method to actually determine success. But if instead of having random generated distribution, we have the actual results.
Yeah, and then instead of the random distributions and hypotheses, you get the results. You check them again, and in real life, actually, your gain would be lower than projected by tests when you roll out the whole people. So, general rule of the thumb: if you see that your A/B tests on real life with real technology gave you 3% gain, do not expect to have 3% when you roll it out.
Okay.
You will have less.
It's ideal.
And false positives, the one that you thought they are working but they are not, when you monitor the tests continuously, it's called regression to the mean. So when you do, let's switch to slides. It's 12:10. Do someone has a schedule?
Yes.
Because it
From
might.
10:30 until 11:15.
Okay.
It's each second part.
And then the next one?
The next one from 12 to 1 and 20.
120.
From 12?
From 12 to 1:20.
It's the so
We already started third.
so we have to make a small break. Let's make a 10-minute break and then I'll explain how this power of the test and p-value actually, well, I'll find power. when you do multiple tests, how they spoil your A/B testing efforts. And this is what you were looking for. When you're not sure about parametric server normally distributed, you get to non-parametric. They're still independent because you do not treat the same people and then check. So if you still can get the means and with the same variance, which you probably do with just shifting the same Wilcoxon runner test, which is in the tutorial just below the test. If not, you have another population parameter. You do not have the means, you have a right tail, and you measure a shift of the tail. And where your tail moves. And it's not in the tutorial, it's as difficult to do as the previous one, it's just 2 lines. Explanation is in the general tutorial next after it. 1, and 2, and 3. Then the trouble is with the manual that it doesn't have references to the Python. It has reference to the math, just with symbols, and reference to formulas with numbers. So they actually show you, like, this is your experiments, you put these numbers here, you get this is what you need. And then at the end, at the appendix of this manual, there are all the tables. So you do not even need to have a software to do all the calculations, but you have to have a lot of things.
And you gave us a link to this, yeah?
Yeah, it's in the reading list already. And it's on the presentation as well. So basically, the good thing out of it that it's not a popular blogger that is just finished university wrote his insights about statistics. It's the validated manual for analysts, which was published 10 years ago, but I do not think that something in statistics actually changed on the level that we can use it.
Yeah, there's a lot of blogs from a guy who just did something.
Yeah, and this is not that. But you have to find references in Python by yourself.
It's not too hard.
I'm thinking to put the Python appendix to it.
Alright.
Okay, just do the calculation around this command.
There you go. Why don't you make it a project?
But there is probable, I will not have time for this.
So you can make it a project for your students.
Yeah, so you get a manual for dummies, but very decent ones, and the simple way to do it without having
Parcele dla Pani te продажи. To jest это карты, но то есть на спектакле
есть и туда.
Есть еще кросс-цел. Не путать сам-цел, как говорится.
So let's start in 2 minutes.
Let's
Oh, it is actually mine. My language lessons.
You take Ukrainian language?
Yeah. This is the,
No, I think that the Ukrainian.
for learning dates, this was the, one of the things. It's, yeah.
For me, I think it is extremely difficult.
I don't remember learning English.
И а что это такое за хардкор у тебя? Это как у тебя буковка отдельно зафрагментирована? Стартап. А YouTube?
Что за еще?
Запустил поиск, потом, когда все раскапывалось, уже на 12 часов нашел аж 50 файликов. Вот сколько ты пишешь? Я имею в виду, здесь ты их еще добавляешь, там плюсики, минусики.
Attempting to, but since the, attempting to figure out what, things are. So, no, it's okay.
Да, я все равно делаю
Yeah, in order even to find that out, I
потом
have
с
to do
поварями
this
затягиваю.
one at a time. It's
Нет, ну только не из этого. Я имею в виду, что именно мы делаем Москвы.
You know, there is a Google translation of that page.
Потому что
I know.
у меня где we are.
This page is making errors. Google said,
Так что ты должен
this page's errors are using only on this page, it's using Google could not do wrong. So,
выглядел список
people go,
кейс-сенсив,
tell
который
us
должен быть очень большой.
nice.
Выглядел список
Sponsor to read it non-standard.
для них сделал все комбинации. Спереди скобка, сзади скобка, спереди скобка. У меня получилось 2400 кусочков, которые я ищу.
Weird experts.
Почему?
Not sure who-
Ну, может, один раз сделаю и все.
But I know.
Ну, надо оптимизировать.
No, this one's too much.
Ну, я написал там вместо Юпитер, я написал Юпитер.
Видишь через пай.
Никому не надо.
So, let's continue.
It's pretty good.
Enough for the break. Do you have any questions about the logic behind testing your hypothesis? Well, I would encourage you to look through or to take the API handbook, and when you'll have another probabilistic situation, just go through the manual as it's written. You do not need to read all 200 pages. It actually sends you, you have to go for each of your step, for your task, you have to go through each chapter. The 5th chapter is 2-page long, so you can disregard it, at least in the book. You would have to look for statistical simulations by yourself if you would need them. But all others, the 200 pages book, it's not about, you do not need all 200 pages. You basically, this is the best page out of the book on the 3rd chapter. You pick which kind of test you do, you select it, you check the recommendations here, then you Google it in Python and do it. That's it. So instead of reading 200 pages, you still have to be on each chapter, but you have to be on 3 pages on each chapter, and there are only 5 chapters. So basically, to run a statistical test more or less informed, you need to go through 15 pages of same book. The main benefit of it that it's not the blog post of some Indian student.
It is not what?
No, it's not the blog post of some Indian student who claims to know something about statistics. They might or they might not, but I've seen a lot of bugs in the code on Medium. The logic can be fine, but there are a lot of underlying problems. Or, for example,
What resources do you recommend?
there is no definite recommendation. That's the problem. Now data science is sexy last few years, so everyone are trying to be popular and write papers, applied papers, repost tutorials. So very often I see tutorials from software packages written as a paper, and not always by the author, with the same example inside. At least the code is right. But opposite, for example, there is some exercises on binomial distributions. Binomial distributions is basically yes or no questions, and there are particular methods that are used only for binomial distributions, like chi-square test of independence, which is not much explained in this book that I recommended because they are more or less specializing on continuous variables all the time. But between statisticians, it's known that you can use t-test, the one that we used recently. When you open the tutorial online, many people will use t-test, but they do not explain underlying hidden assumptions. Because in all statistical handbooks, it's written t-test is used on the values which are normally distributed with equal variance. And the range of ones and zeros, it's not, it's something else. But still, it kind of works. And this is not the worst example. The worst example is some random test, especially because in statistics you have a pile of tests, which you have to be very trained or just take the recommendations. So far, I'm not spending much time on statistics, but so far I haven't seen anything more practical than APA handbook.
API?
Environment Protection Agency. It is in the links. They have another handbook for reviewing, but it has no mathematics. It just kind of have you check the underlying documentation, yes, no. Kind of 30-pager on top of it to be sure that the experiments were conducted correctly. So the fifth stage that we were doing all along last 1 hour, it's the one that is very brief in the book, which is make conclusions. So there is a particular issue in hypothesis testing is what for I've added a simulation. Not my simulation, but the formula that simulates effect of the experiment. This is usually the final check, because this is usually the final check that your experiment hopefully is more sensitive than you expected. Because if you wanted to find a 5% uplift on something, it's better to have better sensitivity of your test, not to get negative uplift and miss it.
So I did that, and that was the tests of, these are probably different distributions were positive, yes, probably different distributions, even though the effect that I put in was lower than what the minimal change of revenue detected could
Because it might be false positive or whatever. That's why if you want more statistical stuff, you either have to click many times or go into the loop, into the function, put your regenerated distributions and see,
Do 1,000.
yeah, do 1,000 of them and get the. And again, from what I've heard, the biggest problem is that statistical tools overly optimistic if something is wrong. So you might notice the effect which is not there. So, potential, I fixed it somewhere. Potential issues. Potential issues in A/B tests. We will do a bit of simple calculations now. So let's see what is happening. Before that, I would like to go through the whiteboard and to cross out all the assumptions that we have at the beginning yesterday. Is it fine? So, assess similarity of the stores. In my perspective, this is a valid method, but you have to use it with very high precaution because a lot of underlying conditions are not getting noticed. And you have to do a separate study, statistical study preferably, which says that your paired stores are comparable. Just picking a couple of rules is not enough to assess similarity. So, how do you calculate the final statistics? For t-tests, we already did it. For other tests, mileage might vary, but in most cases, final statistics. If statistical outcomes are significant, it's what we spend a couple hours for. Then there is stop experiment if there is no revenue growth. We will talk about it next 5 minutes. I'm not erasing this. Changing on-off. So basically, changing setting of the experiment while it is in process can increase the variance, which would make our conclusions are less precise. So I am not a fan of changing things during the experiment. But it's a valid assumption in general. So number of customers, this is just the assumption. Budget constraints. So budget constraints are critical. We were talking here that, for example, it's difficult to train more than 10 consultants in one batch. So it's simpler to enroll, for example, 10 stores or 10 training centers at once in the test, in this kind of test. And here is actually your qualification to understand if budget organizational constraints allow us to make a proper test. Because sometimes they will be too strict, so the test will have no sense. So there will be no point of going through a test, because we will not know that we will not be able statistically significant notice the difference.
So we have to kind of decide either we spend the money for
Yeah,
TNT
yeah,
or we don't bother doing it.
Yeah, or we do not bother. Or we see that 10 is enough with a particular loss of precision, we embrace it and we go for it. That's it.
Yeah. Make higher success change numbers.
Split into pilot and similar, we already talked. It's fine, but I am really afraid of these things. So when I'm checking papers or whatever, and we were looking for the similar stores, I'm looking for a section of the size of the paper which explains why the selection that they've done is valid. If there is just believe us, I usually do not believe. Split randomly. Yes, statisticians love random splits. Pick metric, 6 months rotation, revenue, number of upsells. Makes sense. This is a long metric that you will find out in 6 months, but one of the most important one, because revenue can grow temporarily. For example, if you bombard customers with offers, but then they're getting tired and stop buying. So revenue is important, but long-term revenue is more important. So when you create an A/B test, it's fine, but in generally we have to have a continuous monitoring of the business health. Because even though the test showed that this month everything was fine, it might work differently and we'll see that something is not right. Make receptionists work different schedule. I don't know. Since rules can be very different, it might add a lot of ambiguity into the tests. So it's hard to compare. Once I had a setting where consultants worked in different schedules. So I fixed at least in my head, in the test settings, that consultants were appointed uniformly with the same rules of sets into the best possible time. So this was a part of the technology that was used in the test. If this part later would be changed, the test would the technology theoretically can stop working. But this is something that is beyond my control. So if they work with different shifts, either it's a particular set of rules that you agree to not to control. For example, your manager knows how to do it, and you know that the stores picked the good schedule for the consultants. If someone else will pick a schedule for other stores, it might not work. Or it's a fixed set of rules which are traceable and reproducible. Or it's a separate A/B test. Evaluate other options to spend money. Yes, as another A/B test, or if we are thinking about the outcome and then the potential outcome of this money being spent is lower than others. Because at the beginning of each statistical hypothesis, we have to fix the potential outcome that we're expecting. And then it becomes more or less clear, do we want to play with it or play with something else. Numbers of fitness centers enrolled. This was a magic number, and 20 is better than 10. Mm-hmm. If we have 20, of course. So I do not know why it is magic, because in the manual, in American manual, the magic number is 30, not 20. But still, it's fine. Experiment. This we already talked. Plus experiment about promotion, sales, or give the money to best managers. This is a non-reproducible experiment in general because the managers can change with time and their best effort can be non-reproducible in another store, etc. So, but in my perspective, it's the valid, non-data-driven decision for the business.
I guess for me, it was like deciding, is it better to do something random, something nothing, or this specific thing?
Yeah, but for me, this is more random.
Yeah, this would be the random one, yeah, like this.
I mean, it's not just pure random, it's random based on professional manager's opinion. This can be like a qualitative experiment which derives inspiration for hypothesis.
Yes.
when you cannot really check how it works on the whole network, if it really is significant, but based on the feelings and hunches, we understand that, or reviews or net promoter score increases, or people smile more, we understand that, hey, this might have to be tested in the wider scale. So as the idea generator, this is definitely good stuff. When we're building a business as a system, that would be a system which is totally dependent on the managers. So they're getting to be owners of all the processes inside without actually sharing knowledge. But kind of on the edge cases. Good. So we raised almost everything.
We didn't talk about this stop and experiment thing.
Yeah.
Is there some kinds of rules of thumb about, you know, how much stronger something needs to be an early stop signal, that kind of thing?
No, there is no rule of thumb, but usually early stopping means that you have forgotten to calculate the statistic and you stop prematurely.
No, like original, you would deliberately, like a trigger to stop. To say, oh yeah, no, we're looking for a 1% growth, but if we see 20% decrease, we'll stop immediately. I guess it's inside the power of
Yeah, but they basically have to sit with the simulation and see what are the chances. It's right. But let's go from slightly another side. We're actually from the same side, from the simple mathematical calculation. Let's assume we are in a medium-sized company and we do 100 A/B tests. Or we've done 100 A/B tests. Usually 90 of them will fail because the idea is not working. 10%, well, not the A/B test would fail. 90% of the ideas would be not non-productive, and 10 would be productive. And in our case, we fixed relatively high statistical power, 90%, because in many online trials, 80% is enough. Well, considered to be enough. I am quite careful about it, but what it means, we have even 80 and 10% for the false positive. We have 90 and 5. So what it means that out of 10, only 9 experiments would get to get positive response. Out of 90, well, actually out of all 100, 5, well, let's say out of 90, 5% would be false positives. So 5% out of 9 is 4.5, basically 5. So after 100 A/B tests, we are getting 14 hits. We're happy with the results, they're statistically significant. And positive. So, what would happen with those 5? It's the old statistical phenomena of false positives in sociological tests, in tests of capabilities. When you have false positives, you then get your false positives put in the same room, make the experiment again. Most of them are again on the mean level, and still a small fraction are false positives. So those 5 experiments with time would regress to the mean. So 9 would generate an uplift, and 5 would go backwards. The troubles are with the results with a negative, which might decrease the sales. But that's basically our job, to make an experiment setting so our business do not lose money. So everything looks good. And this, 5 will die, 9 will work. All 9 will work not as good as you expected at the stage of the experiment, but they're supposed to give normal uplifts. So what would happen if we see, so case 1. Case 1. We started an experiment and we planned to run through experiment, for example, 10,000 people, especially if it's online testing. And we are aiming at an improvement of 10%. What would happen if we would see this kind of graph? In industry, many people are stopping the test because they think that they already gotten the result, it looks fine. But the actual power of the experiment happens, kind of gathers to this safe level for us only here. The power of experiment here is very different. Let's assume here we have 5% and 90, and here we have 15% and 60. So our calculations would be slightly different. 15% would give us 15, it's 3 times more than 5, basically, minus 1. So square 5. It gives us 14 false positives, and out of 10 successful ones, we get 6 successful ones. So we had 14, now we have 20 positive ones, but the fraction was 9 14ths, and now we're in a situation where 6 20ths is working. So we are putting, with premature early stops of the experiment, we're putting ourselves in the situation where everything looks fine, but business is not growing.
Because you're reducing the n by stopping.
Yeah. The different thing, kind of, the stopping protocol is the following. You have to recalculate the power of experiment at this stage. If it's fine for you, or for example, if the effect is huge, then of course we will see that we do not need 10,000, we underestimated the effect, so we do not need 10,000 people, it's enough to finish experiment with 4,000 people. So experiment is finished, fine. But if it's just barely hitting the barrier, usually, well, it's frequentist experiments, it does something like this. And it might, kind of, it's a noisy stuff.
But in any case, we get 10% extra, so experiment is, it's fine, so we can continue and we can allow for the...
It's the detection boundary, it's not, kind of, in this case, it's often a minimum threshold below which one we're not sure about the result.
Mm-hmm.
So when we're kind of, if our detection boundary is here, it's fine. When we are significantly higher than the detection boundary, then no problem. But usually we want to make A/B tests as fast as possible or with minimum amount of traffic as possible, which actually means that we take, if we're expecting the improvement of 5% or 10%, we're making the test for the improvement of 9% with a small margin. So if it is touches before and then it falls back, it easily can be false positive. But
Yeah, because sorry, go ahead.
I mean, we can put the limit not like 10%, but like this kind of graph. So in the 4,000 it will be marked at 15,
And that doesn't really. Yeah. Well, basically, the actual limit is not a straight line. The actual limit is this one. But before stopping, you have to recalculate.
Yeah, just calculate it in advance, this stopping line. Because the 14 and 6 and the 5 and 9, they're not available to us. The only numbers we have to evaluate are 6 out of 20 and 9 out of 14.
Yeah.
We don't know which is which.
Yeah, we do not know. So we have to follow the setting, and this premature stopping of the experiments, of the successful experiments, are fine, but when it is informed by statistics, not by the cross of the line. So basically, if you stop the experiment, it's false positive. Then there is another stuff which we partially used in the feeling of some of the ideas was similar. We are doing one big A/B test. Let's say this is a treatment group. We segment all the users in one A/B test. We have segments. Then we do an A/B test, and after the A/B test, we're recalculating the statistics, and we're saying no influence on this group, no influence on this group, no influence on this group, there is influence on this group, and no on others. But we actually we repeated the test X times, and this feels like P hacking. So we're repeating the test, hoping that we'll get to false positive. Because we are kind of recalculating it on the smaller subgroups. So we have to be careful with post-test segmentation.
So, in other words, if we didn't expect this positive influence on that group, so
then there's So if our hypothesis was the growth for all groups, then we take the statistics for all groups. If we'll start to dig deep, all men, women, different ages, genders, etc., even if by chance it will be statistically significant here, you've got a lot of other groups which somehow doesn't interact. Another thing, if you have a lot of positive effects and two groups do not work.
In this case, with one group, so our next step is to establish another A/B test for only this group, just to confirm that the separated effect was.
But just when you have nothing and one group works, it probably means nothing. So this is not conclusive enough to put it into production. In the best case, it's an idea for another test. And the false positive ones, these ones that we have, this one. That's what I said. We thought after the test that they were supposed to help. We monitor them after the launch, and they quite fast go to the mean and do not work. So if those technologies or particular action require spending money, for example, your communication efforts cost money or whatever, when the company is mature with good decision, data infrastructure, etc., these technologies are being constantly monitored. Not all the time, but from time to time, it's normal to throw away old tests. And papers suggest that the ideas that were tested, at least online, the ideas that were tested 2 years ago can be retested again, it's fine. Because the world is changing faster than expected. So, let's do a small talking exercise before the lunch. I've checked on my experience, positive and negative one, some of the companies, and I browsed through a dozen of papers which talk about culture, decision-making culture in the companies. So I would like you first to split in two groups and to make a short list of drivers and blockers of decision-based data in the companies. Both ways.
Drivers.
So basically what promotes decision based on data, what stops companies. For example, you come to a company.
Bad guys.
Да, сюда пошел.
Blockers. Bad guys.
Let's say 5-7 minutes would be enough.
Oh, that's just
Old school guys.
old school guys. I know how this works. This is how it works.
No need.
Misunderstanding that failure doesn't mean everybody was wrong.
Lack of confidence.
Overconfidence.
Support очень
Expensive.
Yeah.
You make your employees go crazy if you're doing this all the time. They like, I'm never working here.
From my experience, lack of difficult to access the data,
Yeah.
and difficult to understand the data, so no metadata, etc.
Sorry, no less.
No metadata, no explanation what is this, what does this field means. Customer one, phone, slash,
экспертиза.
etc.
How are the drivers?
Data culture in the company, which is
Из блокеров только скорость. То есть если, допустим, в компании
The big drivers know what it is, just so it's there. They know that they're staring at it. Yeah, there it is.
and for me also, if we speak about company, this kind of culture should come from the top. The data culture should come from the top of the company. So top manager should not accept any decision without.
Каждая вещь может быть когда поддержка и минусы плюс, да, зависит от компании. У нее там сильная эта часть или слабая.
И еще одно, то, что люди, которые именно в классной математике и
Another blocker would be the timeline.
разрабатывают скорую мировую модель,
Or like you're just based on like the years, like, oh, maybe this thing, and it's like, see his analogy, see how, they spent 5 years in it, and see whether it's one kid. This might not be right.
но вот этот черный ящик перевести на язык цифр, ну, не цифр каких-то, а паранормальных ключей.
If we speak about data-driven decision, what is the target?
Из блокера это
Huh?
There is an American research of two different business schools, but it is slightly old. I haven't seen the new ones. That's significant. There is significant difference in incomes of the data-driven companies. I mean, significant. It means not in times, but it is +3, +5%.
+3, +5%?
But it's not for small businesses. It's for corporations.
Interesting statistics, but of course better to have it.
Что-то рассказывает, у него нет миллиона. Он тут кто слушает, у него есть несколько миллионов.
What I want to say, when we speak about data-driven decisions, I think that there is also
инфраструктуры,
мировоззренческая разница.
может быть, да, не хватает.
Money in system maybe.
Нету диджитализации.
Because there is philosophical different approach, different understanding, two different understanding. So one people make one company wants to implement data-driven decision to make the decision easier.
I don't see what's the reason.
But in fact, you implement data-driven decision to make a decision better, not easier.
I give you an example. But sometimes better, don't you? You just need to have a proper front end data-driven decision. That's it. Look on Google Maps. Nobody, 20 years ago, people preferred to have printed maps because old-fashioned.
Even 5 years ago.
Now nobody knows. You would hardly find a guy who would say, okay, I like this old-fashioned way because it's just you need to have a technology at that level of ability, passion. It turns to be accessible.
But I think you're correct. A lot of these decisions is so you want a decision that needs to be made at the manager level, not to be made lower down, because you can give this person a set of metrics to help them decide. Like you can generate the value of the customer and have that number pop up when they're talking to them.
Implementation will
No, I mean, we use it in our business, like a very simple thing, which is somebody says, oh, you know, I want to do something that's not exactly a thing. It's like, go see the column versus number of visits. If that's a high number, be more inclined to do it than not to. It's a pretty simple decision tree.
Yeah.
And I don't give them a threshold, but I'm like, if the guy wants something special, he's been here 3 times versus 300 times. Sure.
Specific.
Ну, опять это может быть обратная сторона, да, то есть у компании есть экспертиза, это плюс, у кого-то нет экспертизы, это минус, да, то есть это как на такой шкале, да, то есть компания, по-разному.
На самом деле, еще вот это незрелость самой индустрии, самому пока что тогда рождается почему даже с да, интересно придумать, как бы какой-то кейс, да, компаниям,
I have to add one thing to the presentation at least. One of those, I was listening to you on the recall an interesting point.
Там, допустим, там команда, которая разрабатывает что-то такое, они не нашли кейс.
Yes, there are some characteristics that you're not allowed to give discounts based on or to.
Бизнес-кейсы, да,
На самом деле, посмотрите, судится к тому, что надо нанять чуваков, которые что сделают, да, как бы какого-то такого шаблонного движения. И да, если отдыхаем, то как бы отпадает желание
Два раза. Сделали те же эксперименты, получили больше, чем в 2 раза меньше результата.
Sexiness.
И это еще неплохо. 15-60. Может быть не 15. Может быть. И тогда 25 сделали не 14.
для многих людей это
25.
принимаешь решение, выполняешь, и не контринтуитивно, да, то есть, да.
Easier to get money for computers and you get money for other equipment.
Привыкли, да, то есть, там, на кого-то ему кажется, что так будет.
It's easier to get money for technology than it is to get money for other things.
Сейчас собственно живут, он хочет
And banks will lend you money to
No, depends.
technology projects and not to like do physical ownership.
They will?
Oh, yeah, if I went to my bank and said, oh, I'd like to borrow money to redo all the bathrooms because I think it'll cause customer retention, they'd be like, so no, I want to borrow money to do some data-driven products. What do you mean? 100%.
Yeah, this is really high. I mean, it's not high. It works, but there are costs associated with it. Not monetary costs, success costs, etc. Things which you still get money, but you don't get downsides. Because when you take money to renovate the bathrooms, you actually renovate the bathrooms, and this might not work. So you have it, right? Ну как, вы закончили? So who wants to tell two volunteers?
Мы избрали.
Это превысило бы какую-то совет, понимаешь?
Там ее обаяние.
В маленькой группе, да?
So, anyone? Left and right part of the board is for drivers and detractors, not for one team and another team. Okay.
First $50,000 salary for a technology person to help a small business covered by my profits. My profits.
Oh, okay.
Drivers. The feeling that there's a resource sitting there that you're not capitalizing on.
So we have solar says plus, but use no.
Yeah, your database is sitting there, you're like, let's do something.
Another side of this is we can look at this as quite dense markets, big competition, yeah, so and it's a quite, I think there is general understanding, yes, if you want to survive, yeah, you optimize.
Competitor pressure.
It depends, of course, yeah, but in principle.
It will be interesting if one group will be optimist and another pessimist.
Technology optimist and pessimist. Yeah, that's true. I'll tell you. I'm writing notes for myself what to add. So what else?
So blockers is Excel.
Right, yeah.
Hype that it's great for already
You
everybody.
can use everything in Excel. Hype?
Right,
Yes, that's,
sexiness.
yes, I think that 10 years from now it's different, yeah, so it's.
I'll write it down. So, what else?
We put wanting easier decisions, be able to, for a driver,
We're a driver.
yeah. Wanting to automate some decisions and make it easier.
Easier or automate? Or both?
I think probably both.
I insisted on better decision.
Easier decisions, better decisions, better decisions, and automated decisions.
More free time.
Leisure.
But automated is kind of easier, less resources.
Yeah, I don't know, I think those are all slightly different than those.
Actually, each driver can have like a positive and negative feedback because height is not on the driver. It's also it is also has a negative part because height means lots of unprofessional like statisticians and other
Data scientists развиваются.
and also better decisions, not obvious, because you need to like have a translator between statistician and business person.
I've also been
Lack of maturity, what we discuss.
It's like lack of maturity of whole artificial industry.
Lack of maturity of artificial AI industry, right?
Yeah.
yeah.
And actually, we have, I think, kind of a cultural blocker because if we have strong personality on top of the company, he or she tends to make intuitive decisions based on their own mindset because all these CEOs, they are mostly gamblers and they like to
play.
Old guys, that's what we wrote down for the blocker.
Authority.
So
Actually,
that's also a driver though, if you have somebody who wants to drive the business towards data-driven decisions too.
but they want because of
plus and
hype
minus.
or something else. There is a reason why they want it.
Cash.
This is, let's say,
cost, yeah. Or ROI, yeah. Profit versus cost.
regarding the authority, in many places where you can read about A/B tests, everyone states obvious thing that A/B test or testing culture or data-driven culture removes authority of the highest paid person in the room, and there is highest kind of hippo. Highest paid person in the room. So basically, in post-Soviet countries, it's CEO, and in engineering teams or in companies which are in more kind of flatter structures, it's someone in the room. But still, yeah, it's a known blocker. What else?
It's also related that it's very often counterintuitive, yes, that our brain, it's hard to perceive this very often. And also related, as we discussed, there are not really enough or good quality data translators, yeah, who can translate to the business, yeah, from technical point of view to business, yeah.
I'm writing not enough data science managers.
Yes.
Is that fine?
Not enough alumni from MBAI course.
Expense could be a blocker as well.
Lack of competence.
Um,
It's the same.
Lack of maturity in AI industry.
It's industry. It means that you don't really trust the technology, but the organization might have lack of competence.
Lack of competency inside the organization.
On all levels, basically.
Actually, those are connected because if the industry is mature, it's simpler to hire specialists inside the organization, or it's simpler to go and ask, whom to ask.
Oh, but even more than that though, even if you're wanting to run an experiment, you say, okay, everybody wants you to do this, like, you need to have an organization that you can actually directs to do this and have people execute properly. And like the idea of experimentation is talking about actually quite a disciplined organization that they will actually do this stuff, right? You can hire somebody and have the receptionist sit there, and if he just looks at his phone all day, like, it's not a really good experiment. But expense is a big blocker. If you're not doing marketing, this idea of doing experiments would be really expensive. Marketing ones are cheap, but
Most of the marketing is cheap, especially the first versions. Some other things are not expensive as well. For example, if you have a car park, you already put a lot of money to put GPS trackers on the cars and do some fleet management exercises. It's not very expensive comparing to having hundreds of trucks, for example. So some of the things, first approaches of some kind of technological solutions are not always very expensive.
In real life, I have seen situations where the data-driven decisions were blocked due to the fact of the lack of data. And lack of data, it comes from the situation when the company design and implement the product, the process and the product and the database does not take into account management reporting needs. That is why no data, no science, and if we want to put in place some data-driven decision, first we should change the product process. But product already works, it generates already revenues, etc. And so it's another type of decision. You should change something that already works perfectly.
this is why coffee makers come with end-use agreements now. And report home with that.
Can I write it down as poor engineering years ago?
Yeah.
Well, it's not only engineering, it's about how you get the request. The company was ready for a particular reporting question. So it's not engineering plus...
It is not process.
Plus many other things, because not only engineers. It's not only engineers' fault.
This difficulty of implementation, execution, yeah, so that it's not only, let's say, to make data analysis, but also this implementation, support for implementation, yeah, from different departments that causes company pipeline. Yeah.
Support in production.
Yeah.
Makes sense.
I think you could just have some businesses that just, the decisions just really aren't appropriate for data-driven decision. Where there's too many confounding variables, there's too much stuff going on, that you just, if you were in a restaurant and you wanted to change your menu, how could you do that?
I know the restaurants that make first restaurants, at least in some cities like Moscow, some restaurators partner with a consulting company which gathers data from mobile operators to count the traffic in front of the restaurant and which kind of segments of people walk around.
I'm not talking about advertising, I'm talking about like if you want to say...
No, but they modify menu based on who is outside. It's not statistically data driven, but it is insight driven. They gather a lot of things, what is happening around, what are the other restaurants around, what are their menu, what are the pricing strategies. There is data mining tools for dishes and ingredients restaurants sells every day, etc. So I've seen such products. McDonald's, for example, for years, 20 years, have a huge model which predicts sales based on location of the new store. But it's not menu, it's about new building. But yeah, it's some of the things are trickier to make based on data. Or you have to dig into things that doesn't really matter for the business, or not yet matters to the business. Not everything needs to be data-driven. Okay. What else? It looks like we have more blockers than drivers.
As usual. Yeah, it's life, man.
I can tell you a lot about it.
We could do this for getting fit. It would be like 3 drivers and like 1,000 blockers.
Yeah, that's why on average people are not fit. This is some parts, I call it A/B testing culture, but it's same for data-driven culture. Maybe there are typos because I did it late evening a week ago, but still, it looks like a data-driven culture exists or not. I have rarely seen, and I have never read about the companies who have successful data-driven culture in one department and no data-driven culture in other company. And as a consequence, data-driven decisions, data-driven culture has to be taught and advocated inside the company. If it's not happening, probably it will fall back to the drivers, unless it's hard-coded in the process of the company. Then most companies who actually have advanced decision-making based on data, most of them have their own technological platforms to simplify, to decrease friction and efforts which are required to make a decision. Then all of them have strict experimentation policies. And so basically we have lack of competency inside of organization. If it's not the first person, these are being taught, and experiments have very strict settings, so these are being controlled as a process. And the third one, there is a peer review, which happens in most of the organization. Peer review not of the code, but of the statistical experiments. So for example, many companies which do massive experiments, they disclose data of the experiments and they disclose why, what was the idea, how it was built, what happened, and you have an access to the database of all the experiments that happened in the company for the last 5 years, for example. So before doing yours, you can sit, read, and see if it was done recently or longer time ago, what was the outcome, etc. Those companies who actually do a lot of data-driven decisions, when we're talking about massive scale, first they have very high degree of automation of their business processes. So you can plug your automated decisions into something which works fast and not train 20 people, put them all over the country and see the result in 6 months, or just to write a piece of code and send it. But what is important that it's not only automated, but the competency of engineers inside of the company is so high that they can push new updates to automated processes and evaluate the results in very fast pace. So basically, if you have an automated process, you have everyone, kind of hundreds of engineers in the company can influence it. They cannot do, they maintain the knowledge repository. They cannot do, kind of, the experiments are easy, but the experiments are restricted to those that have sense. That makes the experimentation easy when you have all of these things. But there is one catch. When kind of what I'm observing in few cases on local market is the following: the company has no data-driven decisions, and kind of there is no, and there is yes. It's very tricky. Kind of, it always fails, and only in very rare cases you manage to switch to yes. If you switch to yes, kind of you have to do a few steps here, but if you switch, you never get to know backwards. And this is very difficult path. Not only because there's a set of blockers, but there are a few other, or interpreted in a slightly different way, blockers. For example, lack of competency in the company. Well, when we're talking about engineers that are able to do this, they are interested for a particular kind of work experience. It's not about smoothies and 15-inch or big MacBook Pros. It's about challenging and interesting tasks. So when you come to the company which has no culture based on decision-driven, they're not going there. There is no point of any decent engineer to go in the company with a technology which is 25 years old, unless they are being bought for astronomical amount of money.
So it's hard to imagine a company that's not advertising technology company that would need these things.
Yeah. Well, no, it's not advertising technology. For example, Booking, they claim that they are a traveling company which is happening to be great in technology. They're not calling themselves a technological company. They have probably 80 to 100 A/B testing teams, few core teams, but altogether, as far as I recall, they have 16,000 employees.
But they're not testing their products, they're just testing how they advertise the product, how they present it. Which is advertising.
They're testing internal ones, they're testing everything. Everything goes through the tests.
Yeah, but they don't say, oh, we're going to rent hotels, but now we're also going to rent cardboard boxes.
They do. They do.
They rent cardboard boxes.
They do test the things because actually Booking has not one product, but they have few products. They have B2B products, they have backends, they have products for the call center inside, and the call center employees work in a particular patterns with clients, and those patterns are tested. And the way they work with clients.
But when you say different products, we're still talking about hotel rooms, so right?
Yeah, it's about the hotels. It's basically the product for the hotel, the product for a customer, the product for the internal call center, the product for their invoice processing team inside. So when they evaluate the influence of one thing, they're checking all the connected products. It's still.
But those are technology products, so. Right?
No, these are traveling products with high degree of automation inside. Theoretically, we can build a retailer with high degree of automation inside, and it will be perfectly data driven. But those who build that was built years ago in another way, it's very high overheads to switch to a data-driven way. I'm looking into internals of the company like this, and it's super hard to change it on the different rails. As a consequence, engineers who already know how to do it do not go there. There is another motivation for engineers to come to the company. For example, if you are not entirely sure how to do it, but this is a place for learning opportunity. So you're either professional and you go to work with professionals, or you are not professional but you want to become one. So the general strategy of of hiring people. Either you are already good at something, or you give people a good chance to learn something new. Otherwise, you have low quantile of the quality of your technical stuff, and not only technical, kind of any kind of stuff which is technology driven and requires constant improvement of the skills. And that's why we're getting to the same point where most of the companies, when they start the projects, fail. Because these projects have to be accepted by the company. They still have to get someone with experience, create a learning culture inside, convince a top manager, convince top managers, make them understand. And make them understand is not a 30-minute talk in general. It's probably putting a manager to this program and make them study with punishments for a year, so they go through all the courses and they cannot run away, but still learn statistics and data mining and Python, etc. So when an analyst comes who knows more, they say like, yeah, I still understand what you're talking about. So this is long. Then this engineers fight the lack of data. It starts to be simpler to support, but basically this set of blockers, they're all interconnected. And that's the big problem. You cannot take them one by one. And from what I see, especially in the big companies, bringing decision kind of new standards of technology is like a Russian roulette with 100 bullets, 100 chambers, 99 bullets, and one that you would succeed. So the actual problem that there is a lot of variables and all connected. I would encourage you to get to yesterday's lecture to the first, I think, third or fourth slide, and there was a checklist from Fast AI blog on 80 points. And this checklist, it's made for a technical person or half technical person, but under the hood it reflects all the potential troubles that can go wrong in the company. For example, there is a part of the checklist which says how the data science in the company can grow in their career. Can they start be executives or senior executives? Does the company hire senior data scientists as senior executives? Because it is hard to understand. If no, does the company make the senior executives kind of pushes and kind of spending significant efforts to make them understand? If no, it's probably a failure.
In the results of all these experiments that everybody's doing in data science, how particular are the results to the specific zone of operation? Like, are we just in like the raw science part of generating a new set of best practices that if you wait for 10 years, you can just say, okay, here's what to do? You don't need to experiment it, actually, because
there is not much experimentation for the first couple iterations. First iterations are very simple.
no, but I mean as an industry, like is the industry in this sort of stage of everybody's converging on the same, everyone's all doing their solutions for attention, but everyone's converging on the same answers.
It depends. On the corporate level, it seems to be like there is a convergence, but when you start to look for state-of-the-art solutions, etc., like for example you're Walmart and you're interested in the best recommender, then it's not standard product from SAP that you just plug and play and it is the best in the world. For example, in supply chain management, there are few startups, including Russian ones, that build SAP supply management predictive platform, and it's confirmed by auditors, etc. So they created a startup, they they advertise their small product. So when we're talking about the big, best state-of-the-art solution, even if they're insanely expensive, there is always something better. The trouble is that, at least from what I'm noticing, in the big companies, the degree of automatization of the processes is low. Even though when they're automated, they go in patches. So the process looks like few steps, human, few steps, human, few steps, human, few steps value. And when basically to make it work, we'd have to first go from backwards to make it automatic. And then we put some predictive analytics at the beginning, and then it starts to generate value. So it's two-way, actually it's two-stage project. First we make it automatic, and usually it gets to a few departments. This is department 1, department 2, department 3. And basically from what I see in successful companies like Booking, they have this cross-departmental teams that basically take one process. If it's not automated, they automate it. And then they put testing on it, A/B testing, monitoring, and everything that is needed. But to make it across the whole business, again, the engineering culture has to be high. So all things are unfortunately interconnected, and I am not sure if it's possible to bring, well, actually, let's say definitely. I am sure that it is almost impossible to bring decision-making based analytics from bottom-up approach. Organizational culture eats strategy for breakfast. It's nearly impossible to bring decision-making based on analytics if you are a single executive who wants it, unless you're a CEO and you can fire everyone.
Shareholder.
Yeah, main shareholder. Then it works. If you are C-level but the only one, it's actually a dead end, but better than top-down.
So starting the company.
Yeah.
It's easier to start.
Or change the company to those where it exists. If there is an internal political game where a few C-level executives try to change the company from no to yes, that might work. But that's basically the only thing that might work for the big companies. For the small one, it's still about making processes automated, and for this, standard tools would work out. For example, some automatization of the processes based on Azure, or some kind of data management pipelines which require small amount of coding. They wouldn't be as stable, and they wouldn't be able to sustain a super high load. But with less friction, we can get to an automation. There is another way of doing decision-driven cultures. Okay, not another way, but another type of business. For example, a pure retail can hire a statistician who supervises rare tests which involve people or change of the assortment. But it doesn't make the culture decision-driven. It's just the person who says, I do not trust someone stable, let's do it again. So unfortunately, that's it.
Well, actually, we can make kind of a model of decision-making culture of the company, like from no data-driven decision-making at all. That's like a beginning point, and then just to pretty mature with automated processes and statisticians aside, and the number of and also existing knowledge base and lots of business cases for DDD.
Well, a checklist
Kind of
from yesterday. A checklist from yesterday is the best one that I've seen.
MBAI.
Better than crisp DM, etc. But it's very long. I tried to fill it once, even without a person with whom I'm speaking. It took me 1.5 hours, and this was a brief thing. So basically, to fill it entirely, you need to talk with every person of a C-level suite for 3-4 hours. Then top managers, 40 hours of talking.
That's a good contract.
Yeah, except most of them are not fond of talking about things they do not understand. But when they do not talk about it, they do not understand that something is broken. Good. So I think we can have a lunch break. The one that is 1 hour 20 minutes.
I will not be returning again for anything. I'm afraid I have to go. But I'll see you.
Sorry for us. Do you know us, you know?
But I have an obligation I could not do.
Без потом.
Я здесь остаюсь, мне нужно еще кое-что поделать.
Ну, можно покушать. Можно мы пойдем покушать?
Так вы идите, а я остаюсь.